Welcome everybody, welcome to the Live in the Lab with Sigma Prepper. Usually I don't go with this screen first, we just jump straight into the lab view, which is here. We are here. So this is where we're going to be tonight. Don't forget today we have the Sentry Turret that we're working on, which is essentially a security sentry drone, which for protecting perimeter of your property in SHTF Scenario. Is what we're going to be working on, and we continue building that for those that missed it yesterday. I started the project and it was our beta launch of the Live in the Lab series on Sigma Prepper, where I share the survival gear products that I'm building and prototype engineering for you. And you can see behind the scenes how it happens, how it's done. I don't have my earpiece in, so I can't hear what's going on, but I will be listening to tunes while you will be too. Thank you everyone for being here. Thank you so much. It's lovely to see the crew. I really appreciate having some company while we're working away and getting some of our preparedness bits and pieces done. And of course the Sentry Turret for Sigma Prepper will be something that will be made available as an intelligent target tracking Sentry Turret. What can I tell you? It sounds like what it is, put it that way, right? So I'm all, but only because I've just done an SHTF Intel report. So I've just come from already doing a live, so we were already here basically. So yeah, that's what we got going on. Just tidying a few things up, make sure everything's all right on the stream and we're all good to go. And I don't know if anyone's even got any notifications or anything. And you'll notice as well, for those that are joining us now, we did go through this before. We got our thing about YouTube's been removing, shadow banning this channel, removing it from Google, and also now it's gone as far as removing subscribers from this channel behind people's backs. And we just saw about 12 subscribers added and 12 subscribers, the same 12 removed one after another during the SHTF Intel. So we'll see tonight how well YouTube does to stop anyone else subscribing, or when someone does subscribe, it will just remove someone off the bottom end. So this will allow you to see that happen live as we've just done through the SHTF Intel, until they get the message that we know what's going on. Krusty Scab, great to see you. Noelle Marie as well in the house. Daily Survival, moderator of all moderators. So thank you so much. So we've just finished the SHTF Intel, but there was talk of a big earthquake just before going live in California. A 5.4 is it? I thought it was bigger than that. 5.4 in California. This is how she's looking, look. So about here. But it's not a 6 point whatever, it says 5.4. I thought someone said it was a 7.9 or something. So we'll see what's going on. We'll keep our eye on it anyway tonight, so we don't worry, we won't let anything escape us. It'll all be good in the hood. So, with that all being done then, should we get into it? Yes, let's. I noticed just some peeps on the in the VIP after party. We had a little brief catch up with the VIP voice chat there, so they're all talking amongst themselves in the VIP lounge, which is where the patrons go, and they can all talk amongst themselves and hear each other and stuff. So I was just in there just after the SHTF show, the Intel show, and we were just catching up while I was getting things ready behind the scenes. So we're done then. Should we get over there? I think we should. Let's get into it then. Live in the lab with Andy. So we need to, I'm going to come out of shot, so we need to turn this one off. Okie dokie. Right, here we are then. So I should be able to catch up with you in the chat. I'm using a different chair today as well, but it should be all right. It should be okay, so let me know if you see any or hear any problems with, I need to make sure I've got you rocking on here as my monitor. So I can see what the camera's looking at. Okay, looking good. And then I'll bring up my other phone here, and then I can use that to catch up with you in the chat as well live, so we've got all the same stuff we would normally have. And more. It's funny, it's not even putting my own my own video on my own thing at the top, let alone anything else. That's good, isn't it? Thank you for that, YouTube. I literally can't even find my own video on my own feed of Bobs. How incredible is that? How am I supposed to get into the chat? Doesn't let me do it when I go into the back end of it. Wow, do you know what? If it's this hard for me to find my own video on YouTube, I dread to think what it's going to be like for you, is for anyone else to find. Nah. What a joke. So yeah, this is obviously, they're getting pretty insanely desperate. Oh well, I'll have to copy it out of the Discord. So I haven't actually changed anything from yesterday, just so you know. God, dear, what a palaver that was. Sorry, everyone. It took YouTube that long to show me my own video in my own subscription feed. Can you absolutely believe it? This is just becoming an absolute... Right. So first things first then. Sentry Turret. This is how she's looking for those that are new here, and I have to consider those who didn't see yesterday's show. So this is what it looks like. It's a pan and tilt system that's kind of over-engineered to be super strong, super hard-wearing, low maintenance, remote control Sentry Turret that you can mount whatever your imagination can come up with on it, which can be controlled in a couple of different ways. What I'm doing though is getting the power distribution board figured out, which feeds the power to the individual servos. So there's two servos. There's one servo which drives the tilt section up and down. This should be mounted on a tripod. And then there's a second servo down the bottom under here, which runs the pan servo, and so on, right? And so this is the power distribution board that needs to feed each of the servos, and the old board looked like this, which I made a long time ago, which is fine. It kind of did roughly what it was supposed to do. Let's try and sort the lighting situation out. Let's see if that's any better for you. We could do a turning that on as well. Boom. We'll get as much light on there as we can for you. So this is the board that I came up with before, which is okay, but it's just too high and it's been a bit problematic, and I'm going to need to reconfigure this and try and be a bit more efficient with space inside is the idea. So I'm just going to figure out where we're going to mount things, and I'm going to, before I had these servo control modules for pan and tilt, I had these mounted on the receiver. So this is the receiver that receives the commands from the controller, which looks like this. So yeah, these were mounted on top of the receiver, but I'm going to put these one by each servo. It's kind of a plan, but we'll figure out as we go through. And let's move you, can we move you up here maybe to like there? So then this is the demo of the intro sequence with Tia on the controller.
Sigma Prepper. Reject the herd. Prepare the pack. System. Disarmed. Manual mode. Flight camera. OSD. Enabled. Navigation light. Disabled. Flight mode 1. Auto launch.
So she's booted up then, and then this is how we would control with this gimbal. We'll have the tilt up and down, and then the pan left and right as well, is how we're going to roll. And then we've got other
rear camera, flight camera.
We can change the cameras,
camera,
for example.
Camera, rear camera.
So there's going to be at least 2 cameras, right? So there'll be a 30 times zoom camera that will sit on the top deck of the pan and tilt section. So that'll sit on there, and whatever the pan and tilt is looking at, you'll be looking at. I must take this camera off the top, but this will be behind a scope or something like that. Use your imagination. And then you can have another camera as well somewhere else that you can switch to. And then that will be, the video will be transmitted remotely back to you as well, right? So you can just use it as a camera. You can just use it as a camera pan and tilt if you want. And not put anything else on it if you want. Or put it on a solar panel. Put a solar panel on it, sorry. Yeah, put a solar panel on it and it will track the sun. And I've got a drive system that I'm making for it as well, which I'll get into as we go tonight. Let me sort the camera out. So we need to get back to where we got to, which is figuring out what we're going to do about this power supply. I hope the lighting's okay. Let's see where we got to. So first step then is to re-familiarize myself. And we remember we decided that the one that I marked with red was going to be the pan. Yeah? So worth making a note of it. You know what they say, the difference between science and messing around is writing it down. Although they don't say messing around, it begins with an F, but I won't say, it's a family show. But yeah, the difference between science and messing around is writing it down. Oh, right. Losing the slippers. So what we're doing, pan servo, vision lock, which is what it is. Vision lock equals red tag. Okay, so this one here has got the red on it, so we know this is going to be, because I've already set these trim pots up with all the different endpoints and speed of travel, max and min speed and stuff like that, yeah? So, and the guy who designed and invented those doesn't exist anymore. I'm sure the guy does, but his entity that made them didn't. And then this is the 5-volt regulator as well, which we need to sort out onto the board that I made. And this is as far as we got. It's pretty bare. All I've done is cut it out from the main strip of board I had with a hacksaw. We did that yesterday. And I've started working out where, in fact, things are going to go in the design. So this represents this board here, with each square representing the distance between each of these 0.1 inch hole spacings, yeah. So I can count the holes out basically, and we can make sure we don't make any mistakes on the final, because I don't have to cut another one out and everything else, right? So that's the idea. That's what we're going to be doing. We've already drilled the holes out as well for the mounts, which will be these little nylon M2 2mm diameter screw fixings. They're going to be enough to keep that raised off. Raise the board. Raise the board. And then we've got the 5-volt output for the receiver power. In fact, that staggers back one. And then we've got the 6 pins here, which is three pins are for one pan servo, and then the other 3 are for the pan servo, one's for the tilt servo. That needs to be one over. So that's basically what it's going to end up looking like. So we'll need to solder those in. So we're doing some soldering again. Well, we need to be cutting some wires up and wiring the 5-volt regulator onto the board. And the 5-volt regulator will be what we'll use to supply power to this receiver, which runs on 5-volt, or this can run on a few different voltages, but it likes 5 volts, so that's cool. But the servos that I've used in the Sentry Turret main mechanism are good for up to about 8.4, and the more voltage you run them on, the faster and the more powerful the servos become. So they're running at 8.4 volts, and that's why I'm using these power regulators, one for each servo. because they're good to deliver something like 15 amp surge each, and they're also programmable, and I've programmed these to be exactly 8.4 volt so that the servos are being driven at their maximum voltage should they need it to be, right? So that's what we're doing. Now, what I would usually do when I'm building a circuit board like this is I'd start building the layers up from the lowest point upwards, right? So I might even put a little LED in there so we can see when the power's on to make it clear. So we're going to need a resistor for that, a current limiting resistor. Also, I could do with, we need a capacitor, a smoothing capacitor. We're going to have that on the input. Because since it's already, as long as we keep the input of these different regulators, so these are the two servo regulators that make sure we go from about 12 to 16 volts input down to 8.4 for each servo. This is like, does the same job as these chaps, it's just a bit different. It's not, although it looks bigger, this is actually not as powerful, but this is, you know, this is good for, going to be the 5 volt supply. But they're both regulators, so we need to give this an input of raw voltage, and I'm going to use a capacitor, which is like a mini battery. This is 470 microfarads, 35 volt maximum, so we're only going to be driving at a maximum of 16 volt, 17 volt input, given a 4-cell lithium polymer pack. So the idea being is if we can keep any drops, any voltage drops from happening as one of the servos surges and draws more power where it's trying to drive the servo, this capacitor on the input will basically absorb that shock of the servo in the voltage line, and it will actually stop something like this voltage regulator from sort of feeling that drop. But since we're going from 12 volts all the way down to 5, it's very unlikely that we'll see any ripple by the time it comes out of that end. But it's good practice to do, and that's what we're going to be doing as well as part of that board. We'll put a little LED on there to show that it's actually on, so we can see, and then we'll see how it ends up from there. Cheers everybody. Welcome to the Live in the Lab with Andy. Thank you for joining me, my darlings. See Krusty Scab in the house. Just checking out your comments. Lily Sausage. For the space station. I should go to the local chippy and get myself a tuna and banana. Is that even a thing? Tuna and banana? You can't say those two words in the same sentence, surely. Oh dear, it's good to see you with us. Thank you for joining me. Right. So what's first then? Don't know why, it just doesn't feel as bright in here today. I'm gonna have to, oh, by the way, I do have a light coming, a new studio light, courtesy of the Patreon VIP members. So thank you so much to the patrons for supporting the channel. So I've got a new studio light. It's not massively expensive or anything like that, but it should be good enough for the budget to light things like this a bit better than what we're doing. So it can only get better. It can only get better. Right, so we've got some decisions to make. First of all is we need to get this chap wired in. That's got to go in here. That's going to be going that way around into the input of it. This is going to be that way around. Oh no, sorry, we decided we were going to mount that up, that way up in the end, because it serves our purpose, doesn't it? We've removed the what do you call it, jumper pins off there to save a bit of space. We need to fit the capacitor on here. Let's go. You see, it would be nice if we could use the existing. Oh no, we might be able to. No, that's bad practice. I guess we're going to have to go there and there, are we? No, we're going to have to separate it. That's all right, as long as we know that, we can allow for it. So I think what we'll do I usually prefer to keep the negatives on the outside of the board. It's just good practice. So I'm kind of tempted to, that way that we can share this input there and keep that as close as possible. But we know that's going to be on there like that. So we can't really tap into there. But we can certainly go as close to it as we can. I think I want to say there. That looks like it's going to work. So we're going to bend these legs down. Like so. Right. And then this is going to basically go in here, I've decided. What can we get away with? I reckon we can go there. So we'll maybe go there with the capacitor. There with the regulator. Ooh, we're going to have to go over one more. I didn't want to have to, but we are going to have to. See? So we can go about there. That'll work. Yeah. Let's see how the capacitor fits in quite nicely there next to it. That'll keep it nice. And then we've got some space here for some higgery jiggery we're going to need to do with bringing some wires in and out. Although we're not, because I've redesigned that as well now, haven't I? So hold on, let me think this through. So I think I'm happy with that layout. I think the LED to show there's power coming in can go here. Or maybe up the front. I think we'll come up the front, we'll take it off the 5 volt, show it's on. So that's cool. So let's reflect that on here then and see what we're talking about. So we're talking about having one hole showing on the side. So the one over from the one where the mounting hole is, and then there's one showing between it and then it's there. So we got this one here. Is going to be the negative. And then we've got one space. So this is the symbol for capacitor. Yeah. Put a circle around that. So this is the capacitor here. This is 470 microfarad capacitor, yeah? So this is going to be the negative rail as well. So like we've got here, the negative rail, we're going to use this here also will become another secondary rail. And this plus we can extend maybe over to here and use those two tracks. That single negative will be fine up there. So again, this will be plus input, yeah. And this will be negative. So that lot there is basically all the 12 volt input, which will be basically 3 to 4S, yeah? So this is how many cells in series. So 3 cells is 12.4 to 16.8 volt, yeah? That's what we're talking about. And then this is the capacitor, smoothing capacitor then. We're going to go from here into here because we've got this input here on the voltage regulator that we need to go into. So we've got this recess in here, so we can basically come here, can't we? We can come here. This is the plus. We'll go boom. Yeah, to about here. And then we've got the negative next to it. So we'll just do a plus there. This is negative. This is obviously on the voltage regulator. So this is where a wire is going to come in. We're going to need to tag here as well on the negative coming into the negative here. So we can probably plumb in, can we? 1, 2. Not really, but it'll be alright. I was going to use that for the I was going to use that for these cables coming that need to go to these regulators. I was going to have them feeding in here as well in the input, because these need the input top voltage and then they'll knock it down out of there, right? But they need to share this fresh full voltage of 12 volt, 16 volt coming in. So, but I think we can get away with that space there, and we'll dial it in there. If we look at how that looks. How many holes showing? 1, 2, 3. 1, 2, yeah, it's about there, isn't it? Because we need to watch out for this row of pins there. It's going to get in the way of the top. So we are a little bit limited, but I think we'll be right. We can get a wire in here, coming up and onto here. To be honest, these points here, this whole chassis, you'll find the whole thing will be connected to negative rail. So I could connect the negative to any of those points really, but we'll go into here, boom, boom. And then obviously the underneath of it will solder directly on the underneath of here these wires that need to supply the servo regulator boards, power supplies. Yeah. And then I'm going to figure out what we're going to do about these nasty wires here. First of all, we don't need this orange one. We only need the negative and the plus 8.4 volt coming out of there. We don't really need this third signal wire. This third signal wire is from where I program it. Yeah, I can program the microchip on here manually with a special connector thing that I put into it, and I can program this to give me any voltage in increments of 0.01 volt or whatever, yeah. So I think it's set to like 8.39 volts or something crazy. So I've got to figure that out. This wire's all right, but there's not really any point in having these connectors on. The other thing I'm changing as well that I need to make sure I don't make a mistake on is the vision lock systems are now going to be mounted on the servos. So the way the wires are going to run to that are going to be different. They're going to go in line, but they need to be fed with 5 volt is a bit of a pain in the ass, but it's not, because it's fine, because it's being fed by this, isn't it? Which is also giving out 5 volt. Okay. So as far as the configuration is concerned, I just treat it as though this is just in line of the signal with the servo, but the power is going to be dealt with elsewhere. So in which case, these pins will need to come off, and I'll do something else on them, put it in thing. That's what we decided yesterday, wasn't it? Right? So the plan here, these things convert the way the servos work, which I'll demonstrate later on. But what we're going to do is on the servo wire, I'm just going to tap into this yellow one. Yeah? So if you imagine this yellow one, the red and the black wires are obviously just the positive and negative power going to the servo to drive it and give it power. But the yellow one is the data signal that tells the servo where it needs to be, right? Coming from the receiver and so on. And essentially this is a little converter that just changes the way the servo acts. And just in my interest for the way I need this to work. This board is essentially just going to be going in series with that board there, with the wire, the signal wire. So I don't really need to disrupt these power wires. It's just this signal needs to go via this. This needs to come in here and then come out of there. But the problem is that this needs 5 volts to run on, not 8.4. So I'm gonna have to run this up with these pins coming from the receiver, which will get its 5 volt from the receiver. So I think that's cool. Is that right? Yeah. Yeah, that's it, isn't it? So in fact, the only thing coming down to the power distribution board is going to be lich 2 wires. We don't even need the third one here. That's going to end here, and that's going somewhere else to the receiver anyway. It doesn't need to go to the power distribution board. We're in Bidney. We're in Bidney. Let's have a little gurgly drink. Gurgly drink. Maybe we need to get the, let's get this light maybe in a slightly better place as well. I might, yeah, I've got to sort the light situation out in here. Subject to budget. I will. Noel Doll in the house. Great to see you. Still talking about banana and pizza or something. Nasty choices of grub. So I think what we're going to start doing then, just make sure we got stuff in here the way we want. In fact, I need to mark out the fact that we're going to have this mounted up that way for a start. So we know that space is taken up. And then the 5V in, that wants to come out of here. Output's going to be here. So output's going to be basically here and here. And that's negative, plus, this is output. So then we're gonna be going from the output. Where are we? The plus. So the plus here. Yeah, these are going to be wires that are going to be manually going in, but it's not going to go. It's not going to go there, is it? Because that's where the pin for the actual pins is going. So I've already marked that out, silly Billy. There's a reason why that 5V in is already there, and this needs to be. And again, the output, we don't need the negative. We already determined that the negative here is connected to the negative here anyway, which is already connected into the whole thing, since this is the negative line here, which I've got running all the way down to this negative, right? That's why I did it like that. So, because these strips run vertically, so it'll just carry the voltage from the top to bottom anyway. So that's cool. So that works out. What else do we need to worry about? This is one of those measure twice, cut once situations. We need to worry about how we're going to couple these together. So this will be easy. I'll just go link here to there. And I'll do link here to there, where we solder it together, right? So this whole plus there and the minus on the outer edges will be fine. And I think under here, where we've got this 5V, this 5V rail goes down here, right? There's certain things we don't want that touching anywhere else, right? If you know what I mean. And that's where we'll start breaking the tracks, which is where we'll break the tracks of this copper so that the voltage can't flow all the way down the track. So we know we're going to want to break here because we've got this negative line needs to be connected to keep all the negatives connected. We've got a negative here as well. And there's various, well, this is on the tilt servo. We need that to be a pretty solid negative connection because, you know, the servo's taking quite a lot of juice. Where's my... Do they even need to come back there? I suppose they do. Well, I wonder if they do. Since we've only got the power cables coming back, I wonder if we need to go here at all. Because having the pan and tilt on the end is kind of a bit obsolete now. Because I'm moving these to be mounted here on the servos, Yeah. I don't really need to bring the servos in to bring them back out again now. So ideally the servos can be mounted directly into their power supplies. So in which case, what I'd say is to have, I'll be better off having connectors on here that the servos go into. And I don't need anything on here apart from what I'm going to have for this business. So that makes it easy. Am I happy with that? I'm just thinking through the limitations of what it's going to do for me. Because I'm going to need to tap into the servo to these at some point where I've got a slightly different method of, I'm going to reproduce these but a better version basically that's going to use accelerometers and gyros and stuff, right? Proper IMU, inertial measurement unit. Yeah, it makes so much more fucking sense. Let's do that. Let's do that. So we're going to leave those on there. But I don't think that we're going to actually add it on. So where do we need to break the tracks then? Let's figure that out. We don't want this 5 volt coming out of here into there going anywhere. So I think we're going to put a brake track in. What's the overhang on that? Not a lot. So let's put a brake in here. Yeah. Now when we do a brake, I usually put a circle with a cross in it and then I just put a round red dot, and then I know this is going to be severed out essentially so that this doesn't get accidentally connected to the 12 volt down here, right? And we keep it separate. So this one's running up alongside it, but it's not it. This will run up there as well to give you negative. And then I can expand the auxiliary output for as many as I need then. But at least we know the juice that both of these are getting are going to be smoothed, which is all we need. So I think this is the only thing we need to do, innit? Although I need to break these off as well. So I think we'll take it back. We might as well do this whole row starting at this point here. So let's do this whole row. Yeah. So you got the pan and tilt here, look. Which we're not going to use anyway, so we might as well just break those off and then I can use these pins here for something else. But we will need to break that one off. So that's the plan. Yeah, I'm happy with that. It's going to be much more efficient. Much less wiring, that's what I'm trying to avoid, yeah. It's just the best way to connect the servos onto here is the thing. I really don't like these connections, they're just nasty. Whoever made these, look at the state of it. It's even this like sheath here is just not even cut to length. Don't like it. And the other thing as well, I would be... fuck it. So we've got that going on there. Boom. So they need to be... how long? Not long at all. So we're going to cut these down to roughly where they want to be. We'll do some final cutting down in a minute. So it's going to end up being sort of like that. And then that will be... so that's a problem. When that folds over there, I suppose it can twist. it will have to twist to get through there and down, so it can't be too tight. Can't be too tight unless they need to be moved, you see, which we're going to figure out. So we're just testing to make sure that when we solder those on there roughly, yeah, we can still remove the board, work on it, and put it back, you see. So that is about right. I think we'll go about there. Okay, that's looking good. Give them a slice. Boom. So what I'm going to do here is just strip the silicone back from a little bit, maybe about 8mm, so that I can properly twist them up together. Then I'll solder them, then they'll go on. I guess that's the idea. And then they'll be soldered on the back of the circuit board, right? But we'll just keep them together for the time being. So you've got just enough there to get it twisted in. Yeah. Ta-da! Job done. Let's heat the soldering iron up. Have a sip of tea. Ah, yummy. All-American prepper in the house. Great to see you. What do we want? We want some water for the soldering iron. Sponge. Ooh. So this is Andy Electronic Engineering with 4.5 hours sleep or whatever it is. So we'll see if anything goes boom. Obviously not. Everything goes Booyakasha. Okay, what's the plan then? Just sorting my... Do I really need my studio lights on over on my office? I don't think we do, area. Let's turn those off. Right. Oh, getting old. Getting old, son, do you know what I mean? Looking forward to getting her swinging about, I'm telling you that. Getting her swinging. So we just got to drill that out. So we're going to need our little drill bit. We'll solder those wires up. I think what I'm going to do is to remove these. I just don't like them at all. And I think I'll just put pins on, and then the servo connectors can connect onto that directly. I think is a far more genius idea. If I don't mind saying myself. Which means we'll have plenty of space on the board. Okie doke. I'm going to have to, and everybody's asleep my end, you see, so I'm going to have to make my own tea. Although that'll be alright, I can go and make tea. It'll be interesting to see if my radio mic makes it to the makes it to the kitchen. You never know. So we're just going to quickly solder these wires up. usually on my soldering mat, but actually that's not looking very good, is it? Oh, that's alright. Just the way the light was. God, I can't wait to get decent blooming lights, man. What a joke. So you don't want to be melting the solder onto the soldering iron tip. You want to be using the soldering iron tip to heat up the wire and then melt the solder onto the wire. That's usually a mistake most people make. And this is reasonably decent gauge wire. And we want to load it up. We want to load it up reasonably well on the wire because this has got to spread across a couple of tracks on the copper board, and this is the main power going into the servos. Yeah, so it's important. It's see. This one could do with a bit more heat. I need to move this out of the way and use my silicone mat, but I need to get that to start seeping up into the what's it. Okay, looking good. Looking good. So they're just tinned up and ready, and I think what I'm going to need to do is take a quick photo of that. Not that I'll forget, but it's just good to do. Yeah, so it's good to take a photo, just document it, and then you've always got your record of which wire. You see how nasty it is? Look, this is what I'm talking about. You see this? This isn't me, someone else. This is from the factory, right? And these are premium power supplies boards, yeah? So I'll take a picture, then you know exactly which pin's which. Which is an easy way of doing it. Right. Good to see you, Cynthia. Build a robot to make you tea, Andy. Joe, it's funny you say that because my the actual pan and tilt design, this is actually the shoulder joint, if you can imagine that. This is the original shoulder joint design of my robotic arm, right? So this, imagine this as a shoulder that rotates around, yeah? That was like the arm of my robotic arm project, which was going to be playing out a game of chess with two of them on my desk. That was kind of like that was the idea. And then ultimately we'll work up to making a cup of tea. But this is just what I make on my own with zero budget, right? It's much cooler when you're doing stuff for clients and they have great ideas and money to bring them to life, and I get to be involved in that process for them, so I enjoy it. Okay, so what's next? We want to get these off because not likey. Start with this one. I'll tell you what I'd like to do actually is a scalpel. Actually, not that scalpel. We'll go this scalpel. And to make it easier to manage, because we need to remove these one by one, it'll be much easier. So if we just strip it back like that. Do the same here. I might as well do this one while we're here. And then it'll be easier to just pull on one wire at a time as we're releasing them. Yeah. And I won't be using these wires anyway. So So I need my glasses actually. I wonder how long they'll keep me on 410 subscribers for Daily Survival. What do you think? How many years? Glasses. Right, where's my... Need my magnifying glass for this jobby. I really can't afford to mess these voltage regulators up. They're super expensive, these ones. Okay. There's the first one. Second one. Ow! Got burnt by it. Yeah, it's so badly done. And then we'll use my solder sucker, which is here. Yeah. And just tidy that up. Blocked that already. Look at the state of that inside the tube. Look. Pop it in the soldering iron tray. Okay. So we're not going to use that. That's looking good. Nice. Bit of flux. Get a bit of solder oil already melted on the tip, and it will help to conduct the heat straight into the wire easier. So, one. You don't want to be pulling on this, it will just snap out really quick. Just a gentle hold, bear the pressure to put it away. The negative sometimes you may need to boost your soldering iron for, because the negative rail usually, yeah, I don't know how much detail you'll be able to see on it, but the negative rail is usually the whole back of the board is like negative. So when you're trying to heat up and solder something that's on the negative, is the entire back of the circuit board, the PCB, is grounded, meaning the whole board is the negative. On the back, all the copper. So when you're trying to melt the solder, a lot of the heat is being transmitted. A lot of the heat is just going into being absorbed into the circuit board before even the solder melts, right? So bear that in mind. If you wonder why negative wires seem to require more soldering or heat than any other wires, because generally circuit boards, all the spare space on a circuit board, they fill with a ground plane of copper, which just helps to stop interference and signal crosstalk and some other complicated electronic stuff that you don't need to worry about. Oh, every time, man. Oh, it's going to be a, what you call it, I'm going to have to get the little screwdriver on that one. Cool, there it is. Big bit of silver there. Right, let's try that again. Still looking like pretty chunky on there. Just going to put a bit of flux on there. Being a bit crappy, so this will just help to separate the tracks. The solder will sort of find its own place where the copper is and where the copper isn't. It'll just help to tidy it up a bit. Boom. She's sizzling. There's just that nasty bit there, it just looks like it's connected, but it's not. So close. For something as high powered as that, there's no way I would have been putting these tracks like positive, negative and positive right next to each other like that. It's like no room at all, especially for something that claims to be able to do like 15 amps or whatever. Because obviously it means you're limited in the gauge. You're limited in the gauge of wire that you can actually solder on there without it shorting out on itself, right? So obviously we're not going to be using these connectors anymore. So they can go into storage bin. Not much usable about that. So yeah, 33 minutes past 1 here. 32 minutes past. No, 33. Gonna need to make tea as well in a minute. How long have I even been rocking? I haven't even done anything yet, have I? Just been getting back up to speed, basically. We've been going an hour, basically. What have we actually got done? Not a lot, but at least we know what we're going to do. So these are basically going to go up to, what I'm thinking for these is to just put pins on. Just put 3 pins on. I'll only be using 2. Just the power pins, and then the other third one will be there if I need to reprogram it at any point. So we're going to use 3. Whoops, a daisy. Not that 3. We're going to use 3 of them. That's why you want to hold it like this with both sides, and then you don't lose one flinging off into the distance. But basically we're going to be trying to see if we can go like that. Yeah, which looks like we'll get away with. Yeah, and we'll have the connector on there like that. Oh, Anthony, what a superstar. Aliens 1986, remote Sentry, that's the one. Yeah. Although this is to put on wherever you want, Anthony. I do appreciate your super chatteriness. Thank you very much. Streamlabs. Should I say not super chats? Streamlabs are much better than super chats. Well, we'll have a rocking and rolling before you know it, man. Thank you so much for your support. I really appreciate it. Much appreciated. Should we come in? I think we should come in a bit closer. Like that. I'll have to wait until it updates on the iPad so I can see what you're looking at, but I think yesterday it was zoomed in once. This one doesn't seem like it is. But I like how we can see a bit more in the frame. Let me know what you think in the chat. Good to see you, Crypto Sam. Right. Yeah, that's a better frame shot. And look at how it's not very good at focusing. It's focusing on the Sharpie. Look, perfect focus on the Sharpie, but not anything here. But let's force it. So what I want to do for a start, I need to lose this for a little bit because I really could do with the silicon matte. Just because it's grippier, if nothing else, yeah. And look, you see, I can put it up against that top edge, and it's easier to work with, right? So we'll see if we can get. We don't need these out, do we? Move some of this stuff out of the way that we don't need. Okie doke. I'll bring the light in as well a bit closer, that might help. That might help me and you. See what we're doing now. Okie dokie, so let's just make sure it's in shot, and then I'm gonna solder these pins onto here is the idea. That's the idea. So we're going to need some tweezers for that. Here's some I made earlier. That camera doesn't have a clue, does it, how to focus? Bless its cotton socks. I'll tell you what if I just put it directly down like that? Yeah. Because then there's no doubt what you're supposed to be focusing on, is it? There's such a long delay until it comes out on YouTube. It's about like 20 seconds before I even see what it looks like for you and for everyone. So here's the tweezers that we're going to be using today. And what am I doing? What we need to do first, to make it an easier job, we need to tin up. Look at its absolute refusal to focus on the right thing. Never mind. So what I need to do is to get the connector tinned first, right? Look at all this crap on here. See you later. Go away. That can go in the bin. Well, I don't even know if that's even going to be visible, but let's just get it soldered nonetheless. If you can't see, I do apologise. I've done my best. Right, solder please. Here. I need magnifying glass engaged, please. So this is the end we're going to solder in. What's going on with this? Look at all the nasty flux on there, look. That's the problem. So I just sorted my tip out. My bad. Okay, here we go. So we want to basically tin the ends first, right? And then when you try and solder it on, it will go on so much quicker. Come on. Come on, little one. So we've just put some solder on the end of that, and then that will solder on much nicer. So that's the first one, and then we've got the second one here that we'll do as well for the pan and the tilt. Can it even focus that high? Don't know. Let's see, just for laugh. Quite difficult though, where my head needs to be to get in, not be in the way of the camera. There we go. God, I'm just seeing it on the iPad now. It's just like, it literally is incapable of focusing. I do apologise. So useless. Just embarrassing. So, never mind. That's those two done. We need to hold that with the tweezers because that's going to get hot real quick. And I'll have to just hope you can see what's going on, because I'm going to need to see what's going on as well. Now, as long as I get one of these, one of these legs. In fact, I'm tempted to use this heatsink. Not that I really need the heatsink to be a heatsink. That might work. Now, with the solder that's already on there, you see how we're slightly spread across it, look? So we need to just make sure that that center one is on. In the right place, yeah? Look how far spread outside that is. That's tilting right down, that is. Just important that it's not skew. Oh, for crying out loud. Now this thing is nasty. Where's my other one? These are a bit more hardcore, you see these ones? That's going to hold it a bit better. That's better. I don't even know what these things are. Those nasty ones are like some out of Christmas cracker. And we need a bit of solder on there as well before we start messing about. Do you know, I can't actually see it. Because I can't get close enough with my magnifying glass and the camera so you can see being in the way. That's kind of where we want it. You see what a pain in the arse this is? You see what I have to go through? I need to get the one leg down and I can do the rest. Look at it. It's absolutely... Oh, hallelujah. Oh, that's alright, now I can start working on it. I'm getting it sorted. See, as long as one of them's down, right, I can work on the other one and the other one won't move. Looks like there's a small little short there. It's getting nasty. We're gonna stay at that. Gonna need some flux in it. Come on. God, now it's going to be a solar sucker job. Look at the pile on there it's built up. Look at the size of that. Oh, sorry, you can't look at the size of that, can you? Right. That camera's really struggling, isn't it? Useless. Useless. Just that middle one. There we go. And this one here. So it's pretty important that this connection is good because it's going to have like all the power of that servo going in. So it's looking good. That was nasty though. This next one will go much better, you watch. I really don't like these things. They're just nasty design. Whoever designed this circuit board didn't allow for anything. It's not even a true 0.1. It's not even a true 0.1 inch spacing either. Just scratching out a flux in between the contacts so I can just make sure. Yeah, it's looking good. It looks like there's some mess there though. Sorry, I'm just having to inspect something here. Just want to make sure that's just flux and not solder. No, it's fine. We'll soon find out. When we turn it on, it goes boom. And then we'll be on to plan B. So we're going to go there like that. And move some more solder. Yeah, so as usual, YouTube appears to be not notifying any one of my videos as usual, which is fine. It's what we expect now. Right, here we go then. Try and get that one in first. Is that leveled down? Yeah. Sorry, it's just tilting down slightly. Oh no, something want to be like that. As long as we can keep that. That's better. Okay. Looking good. Right, we need some more solder. Let's see what's going on here then. I think we need to get that middle one first. Beautiful. 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 So yeah, liking that. Liking it. So I am going to squirt a little bit of stuff on there, which will probably actually mean it's going to release that. For those who didn't know, IPA 170 isopropylene alcohol is the perfect way to release hot glue, which isn't what I'm intending to do, but that may inadvertently be what happens, because I need to get rid of that flux on here. So I can just make sure that that is not a bit of solder. Let's have a look with my magnifying glass. Oh, that's beautiful. Oh, it's so beautiful. Looking good. Now, you see, it's really important for these sorts of things, for those that think, oh man, isn't he messing around with the smallest things? But the smallest things can be the greatest disasters. The thing with, fortunately, a lot of the prototype engineering that I've worked with in the past has been very much like mission critical stuff. Stuff that's like super important that it always works, because people's lives depend on it, right? And so when you're used to building products like that, you're always straps and braces, right? And so something like just a very small little bit too much solder in one place, yeah, could be the difference between over expansion and contraction over a couple of years of usage, or even not that long at all. You know, you can end up with a failure of a component, right, or a short circuit, worse still, and then the thing sets on fire or something crazy, right? So, well, that's looking perfect, clean as a whistle. See if we can get it to actually focus on it for you, so you can see the two pins, and then of course these are essentially going to be what the servos connect into. Yeah, job done, except we don't need the yellow wire, don't forget, so I'll just remove it from the socket. This is a small little mini servo. I don't know if it actually gave you a good look at the solder on it, but no, that's come out quite nice, and these joints are super hardcore in terms of the amount of current just going to be flowing through them. That middle one looks a little bit dry. This one here, I just want to heat that up when it's dry. When I mean dry, I mean like minimal solder on there. That's the one that for some reason was a real struggle. As long as there's enough solder on that tip, so I'll heat that. To heat this middle one up all the way through to the bottom board. Yeah. And then we got that one next to it now. It's being a right dick. Oh, look. I'm glad I did though, because it's definitely this one. It's definitely this one that's being the right dick. And it's nothing to do with being live or anything. Like I say, it's these boards. Just the stuff that's around these connections with the size connection that it's, you know, designed to be supposed to be, what do you calling it? Passing through it. See, that third pin we don't really care about so much because it's only got a signal on it. It's this middle one that doesn't seem to want to go. It may look like it's alright, you see, to your eye, but I'm telling you, it's just not, it's not totally and utterly. Now it is. Okay, now I'm happy. We're talking 10 amps or more. These pins, right? The pins on these, for a start, aren't even rated for 10 amps, right? It's only because they're going a short distance we can get away with it, and it's not constantly, it's going to be drawing 10 amps at maximum load, but I still have to consider the possibility of it being the case, right? So now I'm super happy, and you'll see they're totally level as well. They're not skew with pointing up at an angle or down at an angle or anything like that. Put the scalpel blade back because, you know, it's not a good look. Stabbing yourself with a scalpel, generally. Look at the state of my tea. What tea? Exactly. Pedigree mongrel in the house. He's at it again. Mr. Bond. Robert McNamara's back as well. So let's come down at a slightly different angle quickly. Right. So it's looking good because I'm liking how sort of effective that's going to be. That's a much better idea. That's going to be so much more effective and efficient with space. Whoa. So yeah, I'm super happy about that. Let's angle it down more like that. Let's bring that over there. Clean this up a bit. We're going to go make some tea in a minute. Not going anywhere. Not going anywhere. I'm just going to make tea. I'm just going to sort some of this junk out. Keep it all organised so we know which of the bits we're keeping as part of the project and which we're not, yeah? And then I can like that. Do. Oh, need them, that's for my pliers, need that. Could hear you shouting in the background. Don't scoop that up, Andy. That's not supposed to be scooped up. Tweezers can go back in the tweezer drawer. Yes, there's a tweezer drawer. This can go in the rubbish. Make sure that's okie doke. Right, where's my pad here? Let's get. Do I just need to angle it down more or something, is it? Do you know what? I know it sounds petty, but there's something that's like really annoying me. So I'm gonna have to sort it out. Oh, it doesn't matter, I just need to sort this out because the line just isn't thick enough, I'm afraid. I'm finding it most annoying. So I just got to tighten that up, I'm afraid. My OCD just won't allow it. Now we're more committed on the size. This is obviously... We're ready to rock and roll now. We can start soldering the board up. Yeah, getting the wires figured out. And then we can do what we're going to do. So we're going to need to have little bits of wires. I can probably do this out of scrap wire. It wouldn't be worth using stuff out of, what do you call it? We still need to figure these guys out. We don't really need... We do need this, but we need the connector to be longer because it's going to have to go to the receiver, and we don't quite know how far that's going to be. But to be honest, I could do with having... You see, these aren't through-hole pins, but I could do with having a socket on there, to be honest. And then I can have a socket-to-socket sort of fly lead going between it, basically. Would be far more convenient. So... Because I definitely don't need that on there. I only need this one thing there with that little triangle, this signal pin. That's all I need to come onto the servo. Yeah. So we need to figure something out with that. And I think, I'm not sure about this. I might steal this one off here. I might make up a new one. I just wondered if it's long enough to go in the case, but I'm sure it's fine. So we're going to be soldering the capacitor in, the voltage regulator on. What else? Sorting the cables out. This is basically done now. We don't really need to mess around with anything going on here anymore. We've got those connectors in, which are going to be cool. We've got our power inputs ready to obviously solder on in place to the board the other side. Yeah, once that's figured out. So they'll be soldered onto there, obviously the other way around. Yeah. Underneath, that will be mounted on the mount holes. So that's looking good. Oh, that feels nasty though. It's got like flux on there. We don't like that. No, we don't. Let's sort that out. It's a real nasty, sticky feeling. Give that a quick clean. It's got that nasty flux, soldering flux, which makes it go a little bit sticky. So again, a bit of isopropylene alcohol does the trick. It's just obviously a bit tricky to get to under those pins now, but it's fine. We figured it out. We've figured it out. We're all right, my son. We're all right, my son. Do you know what I mean? Okie dokie. Okay, I think we're good to go. So it's going to be way more simplified than how it was before, which I'm really happy about. The wiring's going to be really efficient now. I'm not even going to need this hunk of whatever it is I came up with before. Well, we're going to need something similar, but not exactly the same. And again, we'll get to that in a minute. We just need to go straight from receiver to these now, with 5 volt for each of them. But they're not going to be mounted in the same place. And we haven't even figured out how we're going to mount these yet, but we'll be figuring that out shortly in a break. What I need to do is I need to come up with a, let's move it out. I need to come up with a break time, gone to lunch, not gone to lunch. I'm literally just going to go and put the kettle on. So I strongly recommend you do the same. But I need to have some sort of thing that says back in a minute. Oh, I'll tell you what we can do. Hold on, just top of my head here. In a fly, in a panic. Oh, what can we do? I'll tell you what we can do. And the idea with this, you see, is I'm just thinking it will at least symbolise time going by, so people will know it's not a, look, this is like dusty. This is what I'm thinking. This is, I don't even remember where I bought this. It's pretty cheap and gnarly, but it's better than nothing. So here we go. That looks alright, doesn't it? Bit of huff power. Yeah, nothing like a bit of huff power. Ooh, misses. Oof. Polish that rocket, soldier. Polish that rocket. There we go. Right. Okay. So what I'm thinking, look, this is 30-minute jobby, plus or minus 10%. But that's all right, we'll just put that there like that. And then when someone comes, they're gonna know, like, that we're not messing about, yeah? We haven't gone anywhere, it's still going on. I'm just going to see where the image ends up focusing in it and positioning it. Oh, look at Robert McNamara being an absolute superstar. Thank you so much, my man. I need to be able to go. Is that going to work? Oh no, it's that side, isn't it? So no, you can't actually see that very well, can you? But maybe the egg timer. Maybe the egg timer is a thing for people to see. Right, back in 5 seconds. Just gonna go and make tea. I need to sort my radio mic out as well, don't I? So I think it's really unlikely, but I'm in the kitchen right now. I'm wondering if you can hear me at all. It would be interesting if you could. Just doing a range check of the of the wireless mic. It could sound absolutely awful, but I've got the chat going, so I can see. I'll be able to see if you can hear me. You can hear me spooning the sugar into my tea. Oh no, I'm giving away how many sugars I have in my tea. The fact that I have sugar at all. Oh, it's so naughty. But yeah, let me know if it can even reach from here. It was muted until now. It'll take a while to come up. On the chat. Thank you so much, Robert. I really appreciate your kindness. Oh, so it dodges it. Should be better now. We should be fully in bidney now. Yeah. But yeah, I thought this is the next thing is going to be to see just how long YouTube can keep this channel at 410 subscribers. It's becoming quite comical at this point. I think the easiest task for it to do, that it seems to be quite enjoyed doing, is to just limit the number of people who even get to find the videos and things like that. Let me know in the chat if the Discord announcements work. I guess that depends on your own mobile phone settings on Discord though, to a degree, but I'm not sure what other options there are really. At least not anything that doesn't require other people to have to do stuff. How are we going with the old egg timer? It's not really an egg timer though, is it? If it's a 30-minute affair, and you can't really see the sand trickling down, can you? So a bit of a fail really. But I need to find something. I need to do something as like a tea breaky type. I need like a tea break type thing. Scene, animation sequence, or I'm not sure what that should be. So yeah, I'm looking forward to catching up with Robert actually to see what's going on with his back and things. It's seems to be a lot of people getting injured at the moment. We should have a look and see what Tia thinks it is in terms of what day it is today, an emotional, what do you call it, day, which is based on the moon age as to whether it's a happy day, a dangerous day, or most dangerous day and stuff like this. It might have been a dangerous day, but Robert, that you put your back out. could have been a sign. Let's have a look. Where is it? Here we go. I'm sure I had a USB cable here somewhere. Where's the USB-C? USB-C cable, where are you? Have I been robbed? No. This one will do. Right, here we go. Where's she gone? Here she is. Ooh, Tia, Tactical Intelligence Assistant. Intelligence is a middle name. Ooh, boot sequence initiated. Ba, 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 ba. So let's get it onto the moon page. There's the best page, obviously, the Sigma Prepper YouTube page. Here we go. Oh, it's an unhappy day today. Can you see that? Does it let you focus? I wonder. I'm covering up the light sensor, which doesn't help. Because look, have I got the light sensor working or not on this? Not sure. But do you see it says unhappy day? Yeah. That's the moon day today, 3rd quarter moon. Unhappy day. Doesn't like focusing, does it? Look at how badly it can't focus. That's really poor. I refuse to not let it focus. It needs to sort itself out, doesn't it? It's focusing right on the background there, isn't it? I wonder if there's a focus weight or something you can put on it. But anyway, that's the tier moon page. That's the charging page, which just took an inordinate amount of time to do the animation, the graphics, and again the camera probably won't even focus on it. Don't even know if it shows it. Anyway, but so Tia reckons it's an unhappy day today, so let me know in the chat if you felt unhappy today. It's 21.6 days old, the moon, so the day won't change. Oh yeah, no, that did get focused a little bit then. But anyway, you get the idea. Little touch screen. But this is an ESP32 microcontroller that I'm developing for a little handheld tier, a little small version. Anywho, oh, my tea should be. Oh, did I even pour the water in? No, I think I did. I say tea's brewing. It's supposed to be tea break anyway. Hence the sand thingy bob still being there. Oh no, so look, Ghost Cowboy's twanged his back out as well this morning. Dear oh dear. But yeah, let me know if you've had a bad day today. Well, not a bad day, but it's just Tia's reckoning that it's, you know, unhappy day today. It's different for us though, because we've got each other, so we've got no reason for our day to be unhappy ever again. On that note, I'm just going to go and get my tea, and obviously the range doesn't work, so I'll have to just mute it and see you in 5 seconds. Okie dokie, so we're back in the hood. And the best thing about it, we've got fresh tea. Cheers everybody, thank you for being with me. While we get this Sentry Turret rocking and rolling. We don't need that chap anymore. Thank you for your services, Mr. Egg Timer, but we shan't be needing you for a little bit. So you can stay there, go back on the shelf. I'll tell you what we could do. We need some aliens in the mix. Check out these little aliens that sit on my shelf. They haven't got anywhere to sit though. How tall do we need it? Because they need to be watching what's going on. Needs to be a bit bigger than that. Look. Let me know what you think of the little aliens. They just sit on my shelf, look. They're pretty cool, right? Well, I think they're cool anyway. Even if you don't. Oh dear, I'm not sure if they're even in the shot. Do you see their faces? No, not really. Let's go up a bit. Let's try that and see if that's better. My little aliens who sit on the shelf. There we go. Right, let's pop those back on the shelf. You can stay there, little chappies. It's basically a husband and wife alien that got stuck on Earth. They're the ones who gave me the plans. Right, let's sort it out then. What are we doing? Happy twos, everyone. Happy twos. Twos. Right, glasses. We don't really need glasses, but we'll put them on anyway. Might as well. It's worth a laugh. Let's get the chat. Let's get the chat in the mix. Cheers, everyone. Yeah, I don't know if putting a lens on the camera lens will work. Just trying it for a laugh, you never know. Don't know till we try these things, do we? Yeah, look, Ghost Cowboy's got... Oh no, it kind of works. Ghost Cowboy's got glow-in-the-dark alien keychain. Show you guys later. Yeah, man, whack it on the Discord server. It'd be good to see. So we got to figure out what we're going to do with these little guys, which is still remains somewhat undecided to a small degree. And I'll get used to these camera angles at some point in my life, I'm sure. So we need to translate these bits where we're going to be chopping out the tracks on the back so it doesn't carry the stuff over, right? So we're probably going to need to do that. And again, we have to, luckily we've got 1, 2, 1, 2, 3, so we are shifted over 1. But we need the negatives to stay intact. Up that board and this one as well. So there's going to be, we probably will combine these negatives down here and we'll have 2 rails of negatives each side, the plus in the middle. That'll work alright. So I think that's it really, we just need to stop messing about and get it done. So let's get some cable. Like I said, I'm going to use some spare, whatever I've got. Will be fine for this job. I don't... You know, I'm talking about a little tub of spare. This is all silicone stuff, which is quite expensive. Heat proof, you know. This kind of thing. So, what do we want? We need reasonable sized. For the 5 volt, we're going to want something like this. Let's clip my magnifying glass back onto my glasses. So what's this, 22 gauge or something by the feel of it? Can't even find the... We will never know because it's not written on it. But it looks like about 22. Which is pretty good for sort of 5 odd amps, which we're not going to be using anywhere near. But we're going to need some black, similar thickness. What's that black has got it written on? See, that black's 22 gauge. It's about the same as the red, if not exactly. So we'll use those for going in and out of the BEC, which is a really old name for it, battery eliminator circuit. It's basically a 5 volt regulator, right? So we're going to be using these, like these points here, where we've got We need my pointy tool as well. Where's the pointy tool? Sure, I saw that a minute ago, and it's just like totes disappeared, been robbed. Maybe I saw it over here somewhere, that's what I'm thinking. Anyone see a pointy tool anywhere? Pointy tool, where are you? No, that's interesting. That's really weird because I can see it. I can see it with my hyperphantasic vision, yeah, but I just can't see where I'm seeing it. As in, where did I see it? There it is. Do you know, I literally made this tool as a pointy tool. It's just a piece of carbon fiber rod, which is like super lightweight and strong carbon fiber rod. Heat shrink of multiple layers. A little antenna bobbin at the end and then at the other end. Obviously yellow being the most visible colour to the human eye. Yellow and black being the most contrasting to the human eye. So it made sense to put a bit of yellow heat shrink on there, and hey presto, we have pointy tool. Job done. So since I spent so much time making it, we might as well use it. Okie doke. Yummy. Okay, we're back. So first things first then, we need to chop the what's-its out of here, but we don't really need to do that immediately. And we need to decide what's the top and bottom, which we already do. And we know it's going to be the opposite way round, so you kind of got to mirror it in your head, right? So you want to have 1, 2, 3 holes showing, right, on this side. So when you turn it over, it's going to be this side. So you go 1, 2, 3 holes showing, then you know where you're starting from, right? And then we count down 1, 2, 3, 4, 5. Oh, see, pointy tool. We count down 1, 2, 3, 4, 5, 6, 7 holes showing before here. So we got 1, 2, 3 holes showing from this side. 1, 2, 3 showing, and 1, 2, 3. Oh, let's make sure. Yep. 1, 2, 3, 4, 5, 6, 7 holes showing. Yeah. It's going to be here. Yeah. I'm going to have to count that again because that's take my eyes off it. Let's mark it with my Sharpie, shall we? So what we got is 1, 2, 3, 4, 5, 6, 7 holes showing, and we're in there. You see? Sorry about the light reflecting off it. So then what we do, we know that this is the break point. We got 3 holes showing there. We got 1, 2, 3, 4, 5, 6, 7 there, which is what we want here. We just count that out. We're going to count that again because we're going to do this once. 1, 2, 3, 4, 5, 6, 7 showing. 1, 2, 3 holes showing. Boom, and we're in. So now we know we can go ahead and just with the drill bit here, which is about a 5.5. It is 5.5 just from the feel of it. And then this just happens to be a real nice size to just basically twizzle that in there a couple of times. Yeah. And you see that has actually broken the track, right? So then the power won't pass from one side to the other. And it's exactly where it needs to be. And of course we know we're going 1, 2, 3, 4, 5, 6, 7 across. So 1, 2, 3, 4, 5, 6, 7, and again by checking out we know that leaves 2 holes showing the other end of it, which sure enough by the time we've got our 7th one in there we will indeed have 2 holes showing on the other side. So far so good. And I don't think we've got any more tracks to break, to be honest. I think that's about it for this particular board. This is a pretty straightforward circuit board compared to other ones. I'll give you an example. This is a slightly larger tier. The slightly larger tier, which is a full touchscreen display. There's loads of stuff going on in between it as well, with stuff that I've got going on in here. But this is all my own circuit board design as well. I've robbed the IMU inertial controller off there for the new tier version. This is an old version of tier. So there's a little bit more going on with that, and I've got an access hole for a reset button there as well, the main central processor that's inside there, hidden away. But that was pretty compact. For all the stuff that's in there, I won't list all the stuff that's in there. It's got an SD card holder here, which is just basically an SD card converter that I've just wired directly. Just wired the SD card directly on there. I do that quite a lot, it's quite handy. Where's my other little first prototype tier? And you'll see what I mean. First prototype, little baby Tia, where are you? Where was she? Here she is. Yeah, it's probably easier to see on here. Look, I've used a similar technique where you can just use the, in this case it's a SanDisk, like SD card adapter, but I've just wired, these black wires are just soldered onto the contacts on the large SD card into the processor here, which runs, and again this is tier running on here as well, right? But this is a slightly different version. It's got RGB LEDs and stuff on there as well. So that's what's going on with that. But this camera's inability to focus on anything's a bit dodged, but never mind. Okay, so that's that then. We've cut the tracks we need to cut. I don't think there was any others, was there? I think so. So we're next ready to go to the next phase, which is first of all sorting that out with a bit of wire wool. Wherever my wire wool went. Wire wool, where are you? Well, here it is. Okay. I'll do that on the, just on the workbench table here. So I'll show you what I've done when I've done it. Right. So a bit of wire wool, jugga 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 jug. And I'm just going to check that with my magnifying glass as well in the light. And yes, those tracks are perfectly broken. We're all good. Okay, so next up then is, I'll tell you what, this could do with being stuck on here. With just some double-sided tape, I think. This stuff will do it. Yeah. It's pretty, that's not going to come off. And then that'll be fine. Whoa! That was nearly the Sentry Turret going for a wander. I'm just gonna isopropylene alcohol, isolene alcohol, just to make sure that when we stick this down on the board, it's kind of stuck for life, if you know what I mean. And we'll do the same on here. We'd have to be careful that we don't take the pen off too bad. Finish up and dry. And we can stick that on. We'll need to sort the wires out first though. I'm kind of tempted to solder the wires in first, yeah, and then have, and then they'll be sticking out in the air, and then we can just dial them into these two here and these two here where they need to go, right? So that's kind of what I'm thinking, and we can cut them down to whatever length they need to be at the time, because it's going to be easy in trying to thread them in there. Maybe I might be wrong. Now, do you know what? I think it's going to be easy to get that stuck down first, so let's do that. Is that the same width roughly? It is as well, isn't it? Look, it's designed for it. Look at the exact width of the tape compared to the shield, RF shield that's going on, so that's handy. Scissors. And then we can get that stuck down on the circuit board. So this isn't really going to get hot or anything like that. It's not really a heat sink. This is more just an RF shield to stop any switching electronics generating its own frequency transmissions, basically, that can interfere with other circuits going on. Sensitive electronic equipment, and obviously I have got wireless transmissions going on, so I could do without any RF noise, which these metal shields on circuits help to shield against, right? This is so nasty, it's going to have to be a scalpel job, that is. This tape is just awful. Look at it. This is everyone's favourite job, this is. Come on. Thank you. Okay. And then we're going to pop this down. It needs to be just away from the edge. That way. Whoop. Oh, she's already trying to stick down. Not so fast. Not so fast, buddy boy. How's that looking? She's looking perfect. Let's give it some squeezy pressure. And we're all good. So let's give you a bit more of a view up there. So there we go. Looking good. It's not going anywhere. So now we can start getting these wires popped on. And we'll see where we're going to end up. So first things first, we know we're going to be going from here into there, yeah? And then from the underneath, we've got the feed to the individual servo power supply regulators, yeah? So we want this to be sort of maybe the furthest back, yeah? And what I'd also like to do is to have a cable already coming off it to feed the original source voltage coming into something else that I may want to use at some point somewhere else. Like, for example, I may need to have an output going up to a separate module for the camera, which again has completely and utterly disappeared. Where's the camera gone? Oh, it's back there. So for example, the big 30 times zoom camera that would go on the Sentry Drone this one likes 12 volt itself, right? So although a lot of the electronics are going to be running on 5 volt, including my own sort of tier based intelligent systems that are going to be on board as well with extra circuit boards I'll be adding in, but those extra circuit boards are going to go on the top deck, right? And sorry, I'm only just seeing it come through on the iPad now, so I didn't show you a good enough angle of it. This is what we're talking about for the 30 times zoom camera. I didn't quite have it in frame, I do apologise. And then this one at the top would be more like the sort of thing you'd use to look through a scope or night vision camera or something like that. And that will be transmitted back to the base station, your command center, or in my case, the zombie apocalypse command center case. So yeah, we need to go from there to there. So let's get these wires chopped up then. Where's my nice cutters? Here's my nice cutters, my Knipex or Knipex. So we want to be going about from there to there. So I'm going to go like that. And I'm going to do the same for the black as well, roughly the same length. In fact, the black needs to be slightly... No, it's fine there. Oh, we got some camera issues. Just making sure everything's okay. Because on my iPad seems to be just stopped. So let me know in the chat if it seems to have started again now. Yeah, I'm using the iPad as a review. Let me know if it's all coming through to you okay. My iPad seems to be giving me swirly business. Okay, so next thing's next then. We're going to get these cables cut up and tinned up ready to the length roughly we need them. So we've got those two there. We also need to do these two at the front. Let's get you in there so we can see a bit closer. And we need to go from the output over to there as well. So the plus is going to be going, that wants to be about there as well. So they're going to be roughly the same length. And because it's right next to it, I think this one will do the same length as that. Okie dokie, so let's get rid of them then. So this is what we're left with. These are our 4 wires. We've got 4 slightly shorter ones. Sorry, 2 slightly shorter ones and slightly longer ones. And then this is just the end of the black wire. And then what we do, and I usually just use my fingernails. You can just go boom like that and job done. Don't know if you could see that. Yeah. And then we end up like that. Twist up the ends. And then we can solder them up. Oh, should have got the soldering iron warmed up. Let's do that. Let's have a sip of tea. Yummy. Let me know what's going on around where you are. Wherever you are. All right, here we go. We're heated up. And then we're just going to tin up the ends of these wires. There we go. Beautiful. Is this camera showing its inability to focus on anything important again? I think it might be. Got a massive blob of solder on there. Come on. There we go. Yeah, it's quite amazing, isn't it? It always seems to want to focus like way off the frame. It's quite interesting. Right, so that's one. Let's do these others. So we don't need a massive banging out, because we're just going to be pushing these through the holes in the circuit board and then soldering them on the other side is the idea. So we just need them to be pre-tinned enough to solder easily, and obviously by tinning them the ends, melting solder on the ends, secures them so that obviously they don't come unwrapped as you're trying to thread them into a hole in a circuit board. That's the idea. So yeah, I do apologise of its inability to focus. It makes it very difficult for me to try and do this when I'm doing it in a way that's in front of the camera as well. So yes, I'm all funny angle trying to position things so that you can see as well, but I am managing all right. But I'm just saying, bear with me, because the angle I'm having to get my face in it, I can barely even see what I'm touching. Because where my face is, where my face would be, you are, and all you're seeing is fingers anyway by the looks of it. So maybe let's just come up here a bit. Right, anyway, that's that one done. And it's still hot to the point where it just stuck to my finger. And again, same routine on this one. Boom. Boom. And then we'll just tin up the ends of this. Anytime now. I'm having to boost this soldering iron every time. Reasonably thick wire, but nothing too severe. Smoky. And it's tin. This is proper lead solder as well. So I'm getting fumed right out. So this is the fourth and final one. Not the final one forever, because we've got a few others to make up, but for this board here. But I'll tell you what else I'm going to do, which I should have done before I put the board down. Hold on. It's useless. Right. In Bidnet. So there we go. We've got our four little bits of wire. We'll just tidy this stuff up. So I don't have any chat messages on here apart from next to the kettle was the last one, just making sure I haven't missed any or that my chat hasn't frozen, but I'm sure it's fine. So this is going on there. What are we missing then? Now's the time. Oh no, we don't need the negative to go in there, but never mind, because that's already figured in with here, isn't it? But we will anyway. We will anyway. So basically here, we're going to be going in here. We're going to be going in there. Like that. Yeah. Here's what it's going to look like. And then obviously on the underneath, we just got that poking in. And then I'm going to have a plus and a minus coming off there to an external thing. I tell you what, I think I've got one in here that I made up and didn't use. I have, and it's the right way round as well. So this is the cable I'm going to use then as a spare output. That's a bit overkill though. So we're going to need to make a slightly smaller one. Right, sip of tea. So I've got, I'm actually listening in my headphones to di.fm, Liquid D&B, which is basically drum and bass, but liquid drum and bass is like orchestral. Yeah, it's like very mathematical and orchestral type sounding. But that's what I'm working to, even though you're hearing the usual Sigma Prepper playlist that I produced, you know, the music for Sigma Prepper. So, but yeah, that's what I'm listening to. I'm still here, by the way. I'm just sorting something out here. I'll tell you what, I need to turn off the hair light as well on the green screen. Don't need that on anymore. And I could also do with opening the door because I've got this nasty soldering smoke, which is really bad news. I'm even going to put the fan on as well. The main air conditioning fan, because it's not healthy. It's not healthy in the slightest. So 3 o'clock in the morning, we get into low turnout, predominantly low turnout time in Murica. People start settling down to sleepy bye-byes for work in the morning, being Friday when we wake up. I can't believe it's Friday when we wake up. Dear oh dear. But if I get this Sentry Turret figured out, not if, when we get this Sentry Turret figured out, it'll feel like it's been a productive time well spent, because I spent a lot of time, money and effort designing this Sentry Turret to be exactly what it is going to be. And it's been sat in my cupboard doing nothing for about 5 years. So. And I think with all the development work that I'm doing with Tia at the moment, it makes sense because she's the one ultimately who controls it. Just letting the fan blow all the soldering smoke out of the office lab area. I should have an extractor fan really, but again, just sheets. So I have to decide what's the order of events going to be. Hold on, I need to go back into that. Does that show it for everyone else? Doesn't look like it. So I'm just doing something on the chat here. I can't get rid of a stupid icon. Do you know the thing? I've got a love heart sitting there. I think it's so you can send love hearts or something, or emotions or reactions. I'm not sure what it is. Right, let's turn the fan off now and shut the door. So I feel really self-conscious when I've got my door open, because it's like 3 o'clock in the morning. So of course, local residents will hear me messing around and talking, and all this other stuff. Right. So let's make some decisions, because what we need to do is we need to make sure that our capacitor, wherever it's gone, is going to do what it's supposed to do, which is going to be going in here, don't forget, with what, one hole showing, is it, after the thing, and here and there. So we need the capacitors to go in. And we're going to put an LED in as well, I've decided. But it's going to be facing the inside wall. So I'll need to bear that in mind. Yeah. Where was that one going to go? Let's just double check something quickly. This one's going to go there, isn't it? Now bear in mind, I don't need to use those other ones for what we were going to use them for. So instead I'm going to double those up underneath. Unless I go to the outside, which I'm actually tempted to do now. I think we're going to mount that on the end. I've changed my mind on that now. And then it means we've got an extra hole to do something with. Ooh, misses. Everyone loves an extra hole to do something with, let's face it. Be rude not to. But we got to figure out how we're going to get the capacitor over there. Now one way of doing it, you see, is we could reconfigure it slightly. We could go here. We could go there even. And we could go there, right? So we could position it like that. And then with this under here, we can just, we've already severed these tracks here, so we can do what we want up here, right? But this can go straight in. Yeah. We can do that. I'd be tempted actually to just go straight in there. Like that. That needs to be there though. And then the problem is though, we still need to get the negative over to that side. It's not where it needs to be, but this needs to be that side, you see. So that's the problem we got. But at least we can get that leg straight into the positive there, and that's joining straight in, so that's job done, right? And then this one we can bring over. This is the lowest amount of power coming out of this 5 volt here, you see. So this rail doesn't need to be quite as hardcore. I could have done with putting a jumper in there or two before sticking the regulator down, to be honest, but we'll be alright. I'm almost tempted to bring the negative in here though, to be honest, and then go onto the negative there. It's just a bit of a long way to run it up there, but then the other thing is I could do a switcheroo, couldn't I? Now I'm not using these for the pan and tilt now, because it's a completely different design. I can use this however I want, right? So it may be beneficial to maybe have that there. Yeah? That way. No, it's not going to help me, is it? Oh well, it was worth a try. We don't even really need the capacitor's not essential, but it should be on there because of the power coming off the, what do you call it? Okay, so here we go then, executive decision I've decided. So we're going to come in here, we're going to come in this one and this one with the negative, and we're still going to bring the positive in here, right? And that way we can have the capacitor here, and we'll bring this in here, and we'll run it this way, and then up this end here, we're way off camera, aren't we? Do apologise. And then up this end, we'll do it differently. Yeah, fuck it. Okay, that's the plan then. At least I know what I'm doing. So I know this is not particularly riveting, but this is just a bit of a, you know, it's just figuring it out. Because I've just done a complete change halfway through, right? Because of the way I'm now going to be having these next to each servo, which wasn't how I was going to do it before. I was going to be feeding them in here and then bringing them back out again like I had before. But this is already going to be a better way of doing it, but it's just a shame the configuration's the way it's going to be. But it's cool. We'll deal with it. I just don't like the cat. So anyway, we'll do that in a minute. I think first of all, we will just keep that there. We'll put that at the end. We're going to put that at the end, so I think we'll just come straight down into there. And then what we'll do is I'm going to use, let's cut another one of these red ones off, and then what I'm going to do is I'm just going to use that as a small jumper to bring it over. Typical that is, isn't it? Not long enough. Measure twice, cut once and all that. Yeah. And then I'll jump that over, and then we'll have another 5-volt supply as well that we can use, which I will need. And we also need to have an extra output. Warm the soldering iron up again. And we'll need to do the same with the negative as well. We can do that there. It's not the best. It's not the best solution. I'm almost tempted to have that just coming straight off the board, but I don't think it's going to fit. Oh, wrong way around. I'm just thinking, one option is to have that just lich hanging off the end, but I fear it's going to stick out too far. In fact, I'm almost certain it is. Let me just test fit it on the actual pan and tilt itself. Yes, just a little bit too. I don't know. Sorry, I'm just having to test fit it on there, because it would be easier if I could get away with that. So theoretically, if I get that in as tight as I can, if I get it in there as tight as I can, that's actually doable. So what I'm tempted to do is to go in there and there. Yeah, like that. And then I've got this space here to do what thou wilt. And then I can just come underneath for, you know. And it does look like it's going to fit, because it'll be about there. That'll stick out about that much. And then when I actually mount that on the side wall of the pan and tilt, That is indeed, that capacitor is set back enough. So that's cool, I'm happy with that. I'm happy with that if you're all happy with that. And it sounds like you're all happy with that, so obviously I'm happy with that. So that's what we're going to do there then. That's decided. And then we've got that going in up there, so we've got two outputs of 5 volts. And we'll do that to there. No, we won't, that's got to be on the end. Yeah man, looking good. Looking good. We're gonna get this soldering iron up again. Right. Boom. Okie doke. Filling the lab with solder smoke again. Okay, so that's good to go. And then what I'm going to do is I'm just going to jump her over the positive there, which it's not going to do because there's a big fat lump on the end of that. Nicely done. So we're going to do that in there, and then we'll come over to there. We're going to need the tweezers. And that's going in there, like so. You see? So we're just jumpering another 5 volt feed supply over there, and by making it the right length you can see it tucks it under there and it keeps them pushed in, and then I can solder that under here, and that's already split off so it won't go anywhere else. Yeah. So, and we can use a resistor there and drill a hole out there. All sorts of stuff we can do, so we're all good. So let's get that soldered up first then. There's our first wire. And of course I've already wire walled these tracks previously, so there you go, that's the first one done. We are not quite so good wire cutters, just to cut those flush side cutters. So that's the first the first wire soldered in. So next up then, we're going to go from... Oh, we've got another blubber solder, look. At the other end, that's that. And then this is the one that's going to go from here onto there. Yeah, as the main output. And then we've got this one down here, which we need to watch out for because We've got the capacitor going in there as well, don't forget. So that's going to go on there. So might even be tempted to cut that down and solder that on there first. With the tweezers, I think. Maybe. Engage magnifying glass. Tweezers. So this is the input. It's super important we get that super hot. I see it bubbling, we're good. Beautiful. That's that one and that. And then we're going to do the little black one. Or is it the slightly longer black one, isn't it? That plus is quite big, isn't it? We didn't need that one to be that big. And then the negative, which is already in there, but never mind. Where are we going to go? Tempted to go down to the... I could go down... no, let's just go in here. Yeah, let's do that. Decision has been made. Let's clean up the tip. Oh, come on. Oh, come along, old bean. Right, this is going to need some juicy heat. Because it's... as I said before, this is the negative, which is going to have a big gold copper plate joining onto most of beautiful. Okay, and then we're going to pop that one under there. We need to move that one to the side. That one's going to go around. And then under there. And in. Oops. Can't get it in the hole. As they say. These aren't actually the most ideal tweezers for this job. They're a little bit too small, but it's fine. So there we go. It's very much like surgery, as you can see. There's not much in it, but now that's going round and under, along with that positive, and we'll just tuck that in there nicely. And then we've got our two to solder here now. So plus in the plus, negative in the negative, all good in the hood. So let's get her figured out. Boom. Boom. Job done. Side cutters. Bosh. Bosh. Okie doke. And there we go. So now we've got the juice coming in from where we have the main supply coming in there and into the regulator. It's going to come out of there into there. We've got a secondary one coming off there. So let's sort that out. It's all looking good. I think what we need to do though, just to help the soldering, combining the tracks along, we're just gonna take some of this and use a standing blade. And we'll just strip that back, you see, and we just get that single core copper there, right? And then I'm going to use that, if I halve it, yeah. And then from this side, I'm going to double it up so that I can double up this negative track here, yeah. And it will help to, I need my long nose pliers for it, wherever they are. Here they are. Yeah. And then we just bend that over. And then I'll put that, that'll be going on there. Oops. That is going to be a job for the tweezers. And we just feed that in. Can't see anything. Magnifying glass engaged. Come on. Ah. Look at the size of this little thing I'm trying to do with it. It's just a nightmare. There we go. And then that will get it started off for us. I'm just combining two tracks, because I usually don't like combining by themselves. Perfect, nothing sticking up in the area. Right. Looking good, so that's combining up that track for the negative rail, which we'll also double up in a minute and we'll run all the way down to give it extra juice. So the capacitor's going to go. Capacitor's going to go there and there. Smoothing capacitor. And we'll fold that over to double up. The pluses, we'll fold that over to double up. The negs. Main power input soldered from underneath. Not just the main power output. Oh, sorry, the power input, but we need the power coming out of here as well. So let's sort that out then for a start. Let's get this off there. I can't bother to make up another cable, so we're just going to steal this one off here that's already made. It's on it. It's fine. Any other connections we'll do internally. So here we go, this is the power input we're going to use. But you see, the problem is this has got to go on here. Yeah. As well as, but what we also need on here, don't forget, is these chaps. So there's quite a few connections all going on the one, in the one spot, right? So that's why we're doubling up the tracks and stuff. Yeah. So I think I might just strip back the silicon here just a wincy bit more, because we're going to need to rest it down in between those tracks, along with these guys here as well, right? So there's going to be quite a lot going on. So we're going to need the room. So we'll get these tinned up. Magnifying glass engaged. There we go. Ooh, juicy. Not breathing in the entire time, only breathing out what I'm talking. Smoky. Come on. Blob off. Thank you. Ouch. Sorry, I'm just busy burning my fingers. Right, that's that then. I think that back end we'll leave till last. We've got that in there. We need to get the positive in there. The negative's all right, but we need to bend this little wire over and do the same up the other end. So let's do that now. So, beautiful. Tweezers. In she goes. What am I doing? I don't know. If I don't know, you don't know. Oh no, we're going to be doing up here, aren't we? So I'm getting that in there. Let's see here. Oops, sorry, it's the wrong way around. But basically, this is to join the tracks up. So we're doubling up the negatives. Is that one there? Yes, it is. So you can see what I've done here. I've just put this jumper over there with a small bit of single core, and then it doubles up, and then I'll run solder along these, and then you'll have a lot of draw can be sucked out of that without a problem. But trying to combine tracks together without putting a little jumper in there like that's a nightmare. Don't be trying it. Look at that. That is what you call beautiful. Not the smoke coming off it, it's not. Okay, so that's the negative. So let's get this dialed in then. We're going to bung that in there. That'll do. Okay, just figuring out which way around I'm going to have to hold this. Like that, I guess. It's not going to be sturdy enough though, is it, is the problem? Maybe. It's going to be a tweezer job because it's going to get hot. That's nasty. Give that a clean. Right, here we go then. She's bubbling. Beautiful. Okay, and I think we'll come out of there. And we will join up the negatives there as well, and then we're front and back. Nah, we'll be alright. Pointless. But I'll tell you what we will do though. Because that's going to be negative as well, isn't it? So let's do that then. Okay, chop that down a bit. That end can stay long. Since it's going through a hole, this is a negative, so it's probably going to have a load of copper underneath it. There's the ground plane, so this is a real short wire. It's probably going to burn the hell out of my fingers before it's ready. Ow! Okay. I give in. Let's use tweezers. You win. Okay. Just double check that solder joint. This is all mission critical stuff, don't forget. That is looking beautiful. And this one, we're actually going to dial into there. Oh, that's blown it. Well, it hasn't blown it, but it's just totally exposed that. So let's remove that. Nasty. Nasty! Right, let's use this bit. Right. Do that again. What do I want to go for? That end's better. Okie doke, let's try that again. Oh god, I'm just about to do it again. There we look. Beautiful. And then this one's going to go in here. Like that. Yeah. And then we got options, because I'm going to need quite a few. I've got a flight controller that I might use as well, you see. So let's solder that in there. And then we've got another positive and negative over this side as well, which is handy. Side cutters. This is how we're looking so far. Only a couple of connections. Not going to need much more. I'm going to run that solder up there. I just didn't know if there's going to be anything more I'm going to plug in there, but let's have another little. This is slightly thicker. This is 20 gauge, which doesn't even fit in the holes, so it's going to have to be 22, which I imagine is going to be this stuff. 22. Okay, let's freshen it up. And then we're just going to use this. We can't do it there, can we? We have to do it here. Okay, job done. We'll put a little LED in here and all. Although we do have an LED already on the thing, but you're not going to be able to see it. And it'd be good for me to be able to see from the side. So we're going to do that here. We have a little resistor in there. Let's just grab one of these big fat ones. Actually, let's grab a small one. We don't want it to be too dim. So we probably want to go about 680, maybe 5. 680, maybe 1K. We don't want it to drain. We don't want it to drain more power than it needs to. I'm going to use a big fat resistor as well, I think. It's going to be... Sorry, I'm just looking in the resistor drawer for something that... So I think we'll go 680. So this is 680 ohm, that'll be quite bright. It'll be bright enough anyway. And this is coming out of 5 volts, it's going to be fine. So put a little resistor in here. Now what I'm going to do is going to feed it from maybe there, and then we'll skip one, and then we'll go in there. Okie doke, that'll do it. Yeah, let's just do that. Let's just do that before I change my mind, shall we? Yes, let's. Just soldering the resistor in there. Ooh, can we get that last thing out of this weeny little bit of solder we got left? Obviously I've got a whole reel there, but looking good. Okie dokie, so we shoved the resistor in there, which is just going to be what we're going to use for an LED. And I've used the broken track there to bridge it across. And then we need to put this in there, which I think we'll do now. Hopefully it doesn't decide to be a complete pain in the what's-its. Soon find out. Magnifying glass engaged. What are we even doing? Got what we're even doing now. What was I just doing? Oh yeah. Putting that connector on the end, but it's going to be an arsehole, I can just tell. We get one on. The others we can figure out as we go. So, let me position this. Because we get the first one positioned perfectly. Oh fuck. This one's been right arsehole. That's the one. Then once you've got that one done, sorry you're having to look into my hair. Put that away. Okay, so let's move that out of the way. And then I can get these ones sorted. So this is the connector block that's going to be the 5-volt output to things like the receiver module. Beautiful. So you can see here we just soldered this in. So you've got your 5-volt feed, and then this is your negative that runs all the way down to the input. So then we've got this here, and then this will be where stuff like the just a two socket jobby will go in here like that, yeah. But the point is you can have two, so we'll have two 5-volt outputs, yeah, to whoever needs it. Plus I've bridged it over here, so you've got another 5-volt output here for wherever you need that to be as well, yeah. Plus there's an LED going to go in here in a minute. So you'll see. You'll see. Famous last words. But I am just going to quickly, while we're here, I'm just going to check the continuity on the input before we go any further. Make sure we haven't got any silly shorts anywhere or anything. No, we're good. So, all perfect so far. Oh, let's do the same. Let's do the same one here quickly, because these are the ones I don't trust the most. Okay, we're good. So it's going to be super babylish. Super babylish. So obviously we're going to have these chappies held in underneath, plus the main input connector coming in as well under there, loaded up, plus we've got the smoothing capacitor on the input as well. Yeah. So we've got a fair amount going on. That's going to be in there like that, look. So it's looking good. It's looking good. So I'm thinking this needs to be soldered on first. That just needs to be on there, basically. So this is doubled up as well, so we should just get that doubled up now. Well, I just lost my solder again. Why haven't I? It's over there, Andy. Well, I can't see it, so I'm going to have to get some more. So that's the positivo, and that's the negativo. So we're going to load this up basically with, but we need to be careful actually, because we need to pass the capacitor through first, don't we? Good thinking, Batman. Goodio, thinkio, Batmanio, Amikio. So let's do that then. Make sure it's nice and straight. And nah, fuck it. That's cool. Oh, gonna have to open the door because it's well smoky of solder smoke, and it's not good because it's lead. Just getting some fresh air outside. Right. Just having to blow some air through the lab because I haven't got an extractor fan for. We could do with having this on. I have got a fan over here for doing that, but I didn't want to have any wind noise, you see, on the microphone. Right. So I've chopped these off then. Yeah. So the capacitor's in. And then I need to have a sip of tea is what I need. Hello everybody in the live chat. So, we're nearly. Gonna need to be careful off the side there though, because we've got a screw going in there, so I'm gonna have to be careful. But that's gonna be cool, and that's gonna be cool. So that's how we're gonna roll. It's just once I put them on there, it's gonna be difficult to. It's gonna be difficult to hold them on there while I solder these on there as well. Yeah. But I think we'll be alright. I'm quietly confident. That fan's actually blowing it right into my face. We've got to be careful because we've got that thing going in there. So you see how we roll? Okay, and then we just need that on there, don't we? See? Okay, so once that's on there, we're going to be reasonably committed. Yeah, so that's going to go on there like that. Yeah. And then that's going to come in here. Right. So before that we might as well power it up. Might as well power it up and see what it does. Boom! Of course not. Could do though. Make sure there's nothing too much that can short it all out underneath it. Tidy some of this nonsense up. Right, let's just give it some. So you see, we're in business. Got power going on. We'll just make sure we got 5 volt coming out of there, since we removed the setting jumper. Yeah, 5.2. So we've got the 5.2 coming out of there, which is nice. Okay, let's move that out of the way. And then we need to we need to be in here like so. Next, and look at the difference in the low profile for those that saw it before. Epic. So we need an LED as well. Let's find a nice bright one, shall we? I've got an idea of one actually that'll do it. What colour should we have? I think it's got to be blue in it. Although blue LEDs actually take the most amount of current, but I don't think we're worried about it. Let's see what colour this one is. Red. Boring. Here we go. So we'll use a blue LED to show the power's on. Just some old tatty LEDs, nothing special. And obviously you have to make sure you have to get LEDs around the right way. So, boom, boom, innit? That's the other way. Not sure if these are reversed or not, I don't think they are. Don't think they are. Soon find out, see if it doesn't light up. We'll know we were wrong. What's the worst that can happen? I think I'm going to bend that round, so we'll do it this way. What's going on with this thing? Okay, we're in. Actually, let's link that back. So the negative one. Didn't need to cancel out that track in the end. Okay, so when I juice it up, we should get a blue LED now. Yes, we do. So now we've got, and that should light up against the side so I can see it a little bit easier. So she's on. So that's cool. And that's, there you can see it there, but you got a, oh god, where's my pointy tool? Spend all this time making things like pointy tools to not even use them. It's just, it's horrific. Been robbed. It's here. So here we go. LED resistor, 680 ohms seems to be about right. Doesn't need to be much brighter than that, so just be using more juice. Got the capacitor in there. Positive, positive, negative, negative. Power going through. 5 volt coming out this end. I've got a spare here to do what's something I want with as well. So I'll probably put another one of these connectors on, but for the time being that's fine. What I need to do is to put on the feet now. Yeah. So we can put the little standoff feet on there now. Just only needs to be finger tight. Yeah. So we'll bung those on all around. And then that's what we'll mount into the frame with, right? Whoops. These are nuts. Whose nuts? These nuts, of course. Is that the wrong side? It is the wrong side. Okay, get in there. Nut. So these are little 2mm nuts. M2 nuts. Who's nuts? M2 nuts. Don't want to go too tight because you'll just end up stripping the thread, which is never a good look. See, this will be the point where they'll be like, this is the point where you realise there's something missing. Yeah, it's like, oh man, I should have done that first, or oh, I should have soldered that wire on first. Oh, Connie Richards, what an absolute babe. Thank you for showing your brilliance with that. You're amazing beyond words and pulled off 3 shows in 20. Is it really 3 shows in 24 hours? It is as well, isn't it? I don't really call this much of a show though, but it is now. You're doing super chats, my darling. Love to you and Jenny. I hope you're all well, my darling. Thank you so much for your kind words and encouragement and stuff. And even when, you know, YouTube's doing everything it can to destroy this channel, you've got people like you keeping it rocking, so thank you so very much. We can do it without them, right? So here we go then, look. Little feet. Question is, do the feet line up with the holes? I guess we'll find out in a minute. But before we do that, obviously we need to get these last wires in there, right? And she's looking, I mean, come on, don't tell me she's not looking awesome. I'll tell you what, the constant floppy of this capacitor there, I am going to put some hot glue on there. Yeah. I'm going to move it slightly away from there as well. Just going to double check, make sure the sidewall's okay on this. It's too late now if it's not, but never mind. No, that's alright. That's alright. Okie doke. Happy with that. Muchos happy-os amigos. Muchos happy-os amigos. What else we got to do? I don't know, but I need to turn the fan off and shut the door. Although we've got to do some more smoky business, haven't we? With the soldering, so maybe we should do that first. Yes, indeed, I think we should. Just don't like having my door open when it's really late at night, because people probably hear me chatting about. soldering fan to over this side. And it will blow it back the other way. Not got much tea left, look. Right. What's next then? We need to get that soldered on there, don't we, is what's next. So we kind of need to be doing it like that. Yeah. I may need to take this one out actually. I was thinking it would be a problem if I didn't have it in, but I think actually it's going to be a problem if I do have it in, because it's nylon, it will start to melt. But as long as I remember to not stray too far over to the left, otherwise we're going to be infringing on hold on, this. Sort the fan out. Right, so this is the final wires on this part, and then we're going to be working on the. Oh, that's nasty. State my soldering tip. It's a disgrace, I tell you. I'm going to need new soldering iron tips anyway, to be honest, looking at the state of this. Starting to get eaten away, which is normal. Right, let's go. Just hope the whole thing doesn't fall apart. Ouch. That is... It's one of those things that's like unbearably hot. It's unbearably hot, but I can't not hold it, because otherwise the whole lot's going to mash apart. Ouch. That's just not going to do. I'm going to need to use I'm going to need to use the I'm going to have to use these. And hope the lower one, hope the bottom one stays intact. This is what I didn't. This is what I was reasonably. Oh god. The fact that this thing won't stay still is really annoying. Doing it again. See, this was the bit I was saying to you was going to be a right nightmare, because I've got 3 of these things loaded up on top of each other, which is just really not a good look in the best of days. Oh god, look at the state of this soldering tip, man. It's all falling apart. There we go. Okay. One down, one to go. It's not even the right solder tip for this. I should just put the other solder tip in, but I just don't want to have to wait for it to cool down and then heat back up again. There she goes. Forceps, please. Have a look, make sure she's looking all right. She is solid. Solid as a rock. Beautiful. So let's put the little standoff back in then. Now it's cooled down. Oh, look at that. Oh, you see, I knew that was going to be an ish. There's not much we can do about it. It's fine. I'm just going to have to scalpel a little bit off this standoff because, like I said, the solder's going to be a bit of a what's this. Is that going to be long enough? Not really. Okie dokie. Little bit of surgery. Yeah, we'll have to squeeze that in. I don't know if we can get that in there, can we? Yes, we can. Okay. So this is how we're looking then. Okay, looking good. So we can shove these screws in here now, if they even fit. If not, we've got the metal ones we can use. I don't know if these will fit through the aluminium, will they? Not really. So, oh, that's probably why I had these ones out, was it? I don't know, the 10mm ones are going to be. I don't think there's any other size of those plastic ones. These look well long. Nah. So in that case, we will just double check. No. However, what we could do is use a little standoff to go in the standoff. Even that's not going to be long enough though, is it? Yeah, that'd be alright. And then we've got options on the bottom then. Although I don't really want that getting in the way of that, but we'll see. Yeah, I'm thinking, well, I'm just not liking that. So instead, we'll have to use stainless steel screws. These ones are just not going to be long enough. And 10mm are going to be too long, so we need about 6mm. 3mm aluminium is going, aluminum is going through, as you would say. Night night, Robert. Night night, Robert, my old son. Here we go. $6mm. Or 8mm. That leaves 5mm sticking out. No. 6mm, do it. $6mm. Uzi 6mm. So 4 of these. And we can get that rocking in there, starting with the nastiest screw first. We need small little Allen driver. 1.3mm. 1.3mm. In there. Beautiful. Look at the beauty of it. Looking good. So much better than before. Yeah. Epic levels of betterness is what I'd call it. This is the one that's going to be slightly more of a challenge because it's the one that's got the can't even see it. It's the one where the it's got the solder next to it, so it's a bit more of a struggle. And then last but not least, so luckily I made these holes in the aluminium ages ago and I happened to make them. So check it out. That's pretty nice, isn't it? At least I think it is. It's nice and contained, it's not going anywhere, it's all secure. And it's so much flusher than it was before. Yeah, low profile. This was banging up against a thing and it was actually causing a problem with the cables. So we need to plug this in and we need to make sure we get in what we expect to be getting out of here, which is 8.4 volt. There or thereabouts, yeah. So that's the plan. Well, that's the expectation anyway. Don't want to risk shorting these out, so I'm actually going to apply the probes first. Pretty sure it's those two, just from memory. I guess we'll find out. Right, juice please, Maestro. Juice please, Maestro. Boom! Oh, we're in Bidney. We've got LEDs. We've got two green LEDs in there, so that's already a good sign. And we can see on the display here we're showing 8.34 volts, which is what I'd expect. So let's just check. Let's just check this one. Pretty sure. Oh, is that the negative one? Doesn't matter. It will show me either way around, won't it? Let's see. Yeah, look, 8.3. 8.33, which is where I programmed them in to be. So that's cool. We're looking good. And look, you can see the glow. You can see, if I turn the light off here, look, you can see the lovely glow of the LED that I put on, which is obviously the idea is when I'm seeing it from the side. Yeah. It will light it up so I can see its power's on straight away. So if there's a problem with it, I'll know it's not, the power's not getting through it, right? So I'm happy with that. We are rocking. Of course, we've got the 5 volt coming out here as well for the receiver module. Yeah. So the next stage. So super happy with that. As should everybody be, because now we don't have to worry about doing up circuit boards anymore. So that's how that's come out, and of course we'll be addressing the servo outputs. I just wonder if these are worth heat shrinking. Don't know. Just in case if these come loose inside, you see, and start flapping around. Yeah, and I also need to be bit of hot glue on the capacitor there to stop it shaking around with any vibration that will over time weaken those legs. Micro vibrations over time. So I think I'm tempted to heat shrink these and then secure them down. And it also means I want to mount these shifted back very slightly from where they are, which for two reasons. First of all, I could do with a little bit more slack on these here, because you can see, pointy tool. You can see it's pretty tight going around there. It's not epically tight, but just because of where this is going over that side, it's still tighter than I'd like it to be. So what I'm going to do is I'm going to heat shrink these separately. I'm going to remove them, heat shrink them separately, and then remount them on, but shift them up that way so that this is a bit looser, and also so that when the sockets on the end for the servo connector, yeah, there's not going to be too much sticking out here that can get banged as well. Right, so that's the idea. So the best way to remove hot glue, because these are hot glued on, right, is actually just IPA 170, and I've just sprayed a small little bit in there, yeah, and as that works itself down, boom, see how easy it comes off with the alcohol, right, straight away, isopropylene stuff. It just comes off immediately. It's quite handy. need to clean this because we'll need these when we stick these back down. We're going to want them to be seriously not going anywhere, because if anything comes loose inside the Sentry Turret mechanism, it'll just be eaten alive. It'll just be eaten alive by the gears and stuff. And obviously that will short circuit a bunch of stuff out, and you've got quite a lot of high power battery bank that's going to be mounted on the top, which will mean obviously the risk of, well, fire essentially, yeah. So here we go, I've just removed those from there. I'm going to heat shrink. I'm going to put these two chaps in heat shrink. Yeah, and then they're going to yeah. Nah, they're fine where they're going. And in fact, then I can mount them up that way as well. Is that gonna... No, it's not. We need a bit of clearance. It's a shame they're twisted over like that, but never mind. But we definitely need some heat shrink action. So I'm gonna do that now. We'll find some heat shrink that's suitable size. I'm going to go and put the kettle on quickly as well. Time to okie doke. Right, I think it's time to have some tea, so I'm going to go and put the kettle on quickly, and I hope you'll join me in a tea or a coffee or whatever you're drinking, and then we're getting into the next bit, and then we'll be firing her up. Fire up. At least that's the theory. Look at the state of my desk now, see? Doesn't take long to completely... Yeah. Doesn't take long for the desk to get pretty... What do you call it? So I'm just sorting a camera angle out. It's interesting seeing absolutely zero... nothing going on with YouTube. Doing anything to help this channel do anything, which is just amazing. That was the whole point of the top right there, just to show the complete and utter, I don't even know what you call it. Definitely need to sort out some sort of a gone to lunch page or something though. I haven't actually gone to lunch, obviously. Yeah. I ain't gone to lunch, nothing or nothing. Right, so we're going to make tea, and then we're going to sort out those vision lock sensors. What else? Yeah, we'll mount that back in there. Okay. Right, let's go and do the tea thing. Join me in a cup of tea, back in 5 secs. Just gonna, I'll leave my glasses there, can be the symbol. So back in a minute. So I'm munching on some chocolate. Just back from the kitchen. So tea's brewing. We are brewing. Yes, sirree, Bob, ma'am. We are. Right, let's get some heat shrink tubing out while we're here. So they shouldn't get too hot. Those voltage regulators. So I won't need to worry about that. In fact, they originally came in heat shrink anyway. Heat shrink tubing. Let's get the right size. Oh, look at that. Absolutely perfect. We need to allow for shrinkage. So maybe it's going to basically end up being about there. I'll make sure the other one was exactamundo the same. Looking good. There we go. So what we're going to be doing is just heat shrinking over these circuit boards here, which are the voltage regulators for the servos. And that'll just make it less of a complete liability hanging around with exposed surfaces, right, inside the mechanism. Hopefully we'll get it to fit over that end bit. There we go, a little MOSFET chip at the end there. And obviously we need the connectors to end up out there. We need to remember which is the right, which cable's which though. And then I can go and get my tea, which should be finished being brewed. Push that through from that end. That's about it. So there we go, these will be like that then. And then I'll have to mark which. Obviously we don't want to get in the way of those two screws. But it's fine because we can just remove it using the nuts. We can remove the circuit board using the nuts. Whose nuts? These nuts. So yeah, that's the plan. Which, so far, I can't see any problem with. Not unless I get any funny surprises, but I'm not expecting any. I don't like how tight those wires are, but never mind. I suppose it's not really tight, is it? Oh, I need to sort out. iPad battery is super low. One, two. Microphone's fine. Okay. Everything's charging and looking good. Right, let's go and get my tea, which is brewing, and then we'll do the heat shrinking and the gluing. Okay, back in the room. Right, sorry, just checking some stuff out. Right, we need to do some heat shrinkering. But we need to make sure we know what wires what. Which is fine, because I took a photo of it, so I know. Yeah. Back then. Plus. Okay. I left my tea over the other side of the office. That's not a good look, is it? Right, here we are then. Let's get the blowtorch out so we can do some heat shrinkering. I just could do with a decent way of symbolising which pins what. I know what it is now, but in a long time's time, probably not. Probably not. So that's fine. Okay, I'll tell you what we'll do. We'll put a yellow one on the yellow one, and then I'll already know. Just from deductive reasoning point of view, it'll be obvious. So I'm just going to use some yellow I'm going to use some yellow heat shrink here, and I'm going to put that. I'm going to need 2 yellow ones actually, because this is for programming. This is for programming these. What do you call it? Right. In fact, is that even thin enough? Let's just see if I've got any even thinner than that for the yellow. Doesn't look like it. That's pretty small stuff, to be honest, but nah, it is what it is. So we'll just chop it down a little bit more. We only need a small little ring of it. The first bit chopped in half would have been fine. Okay, I'm happy with that. So what we're going to do is just heat shrink these, and we know that this one here is the signal pin for programming, so we don't need to worry about that. So we'll do one at a time, and for this task I'm going to need to turn my soldering fan off, and we're going to need to spark up the blowtorch. It's just a small little one. Okay, so now we can start shrinking. Ideally you want to get it so the heat's rising up, but it's not always possible. Okay, looking good, and those pins are totally exposed. That's nice. Okay, one down, one to go. The one on the right hand side. Light the blowtorch. Not too severe, so we'll set fire to it, we don't want to do that. Make sure that separate pin one's on. I'll keep that one around the back. Keep that around the back, and then we can start shrinking this one down, just like the other one. There we go. That's totally flush, and that's totally flush as well. There we go, and now we have our 2 power supplies that we can now stick down, and I'd be inclined to use industrial tape for this, because it's actually going to be more reliable than. And look, the wires aren't touching the side plate at all as well now, which is good. This is what I wanted. Just form those wires around that curve. And that's looking pretty good. And I know that the left-hand side one is negative and the middle is positive because it just is, as you see here. So the color coding is the same. So I know by just covering this one, which we're not going to use, the yellow one. This is for programming the voltage regulators. But they're already programmed to 8.4 volts, that's cool. So this is our power supply on the back, so we've got a 3 volt, we've got the LED in there, we've got the output as well, 5 volt output for the receiver module, for the Sentry Turret control. So that's the plan. So let's get these stuck down then. In fact, I'm actually inclined to use one slightly thicker strip maybe. because the width of those two together is exactly the same width as that tape. So yeah, it's decided. That's what we're doing. So then we need the length of the tape to be the length. Where's the scissors? Oh, I think I just poked you in the face with the scissors. So probably something like that's going to be good. And then what we can do, I mean, ideally this entire thing could do with being switched over the other way, but we're not going to worry too much about it. But we don't want it to be too far. Okay, so we need to be, where do we need to be? Literally from the screws, pretty close up against there is where we need to be. So up against the screws, we can come down on that slightly. So let's do that. Let's go there. Okie dokie, so then, there we go, you see. So we're gonna go just a little bit. Oh no, hold on. In line with that, just up to the screws. So we can still get to the screws, basically. There we go, so we'll stick that on there. And again, this tape's super nasty, so we'll be using the scalpel for, in fact, I prefer this scalpel blade for this. Although it's not particularly sharp. Okie dokie, so we'll start with that one, which can plonk down there. Man, this is going to be so much more compact to how it was before. Although that definitely wants to be the one that's going that side. And then this one, right up alongside it. Whoop, there it is. Beautiful. Beautiful. Yeah, that's much nicer. Much nicer. So much more beautifuler is what that is. Okie doke. I wonder if we took... Yeah, we're going to work on the servos next. But that is a million times better. We need to hot glue the capacitor. Stop that vibrating around. So let's do that now. And then we can move on to the Sentry Turret main mechanics. Okay. Let's pop this there. So we've got silicon mat. Silicon mat. Probably not going to need all that. These can go back up. Got way too much stuff sitting out here. So the hot glue gun is actually heating up. So let's not forget that. Yeah, it's getting warm. Just finding a good angle. Pointy stick, tweezers can go back in. Just having a quick tidy up while the hot glue gun is heating up. The 12-volt regulator we're not going to worry about just yet, so we'll keep that to one side. And we need the end protectors for the tweezers. Oh, we haven't actually included additional power coming in, but I think we're going to figure that out somewhere else. Here we go, we're starting getting hot glue splurging out. That's when we know we're in business. With the hot glue splurge, we know we're in business. So we're going to lift up very slightly the capacitor. Shove some glue in the side there. Do the same in there. And then just cooling down the hot glues in there. Black hot glue sticks we got. Yeah. And then it will hold that capacitor still enough so that you won't end up getting that capacitor sort of wobbling around. Just pull that hot glue stick back out the back slightly and it will stop it dripping out the end while that cools down. Let's turn that off. So yeah, we've got the capacitor hot glued in there. Yeah, that's nice and sturdy now. So yeah, like it. Like it. So yeah, we're looking good. We're looking good. Whoa. Yeah, man. Super solid. So let's work out what we're going to do with the Sentry Turret mechanism then. Let's move some of these things out of the way so we can see what we're doing. A bunch of these drawers I can put back in my lab stock and that. Crusty Scab still creeping around in the background there. Good to see you. Thank you for being with me. Just keeping me company while we're beavering away, as they say. Aren't we a lot of beaverers? I've been so engrossed I haven't even had a sip of tea. And now I have. So 5 to 5 in the morning. This is how we roll. Okay, let's get rid of the hot glue gun now. And the silicone mat. That can go over there. We don't need the hacksaw anymore. So the hacksaw can go. Okay, let's sort that out then. See where we've got to. Not quite sure what you can see there, but I'll soon find out. We'll sort out our workspace here, and then the files can go. One talking metalworking files. Sorry, just getting the space organised a bit. Let's move the lamp out of the way. Right. So we might have to make up a cable or something in a minute. We'll see. Just put some stuff back in their drawers. So I'm just having a quick tidy up. Boom. And then, because I needed obviously a decent amount of space to get the turret system in here, in the mix. Right, let's pop this down. In fact, I think we're going to take these sections off for the time being. They don't need to be on. We haven't even bolted them down yet anyway, so. These are for the antenna mount. These are the antenna mount plates. Obviously you get lots of different mounting plates. Oh no, we've already put some screws into that one. Have we or not? We have. Just one. Nothing we can't sort out, so let's quickly let's whip that screw out quickly. Where's the extra screw? They're up there. Got a box of screws here. So I think that's the only screw in there. Looks like it. So the back is the side with the spirit level. Pop that over there. So we need to be this way around, basically. So the next problem we got is fixing these servo controllers, basically. So we need to be finding somewhere for these to live because I still maybe need to modify. Information. So this is the thing we've just built, right? And built the strip circuit board for. And so that's basically going to go in the side here. It's essentially the same plate as this one. Although it looks like we're going in that way. Judging by the step down here, you see? So that's how it's going to work. What is it even? Just trying to figure out what the camera was even focusing on. So it's going to go down to there. I want to see what the... Need to see what the actual... Where the capacitor ends up. So he's just seeing what the clearance is on this. Yeah. Looks like it's going to be alright. Yes, plenty of room there. Where's the... Here they are. Just want to make absolute sure that the capacitor there isn't going to get in the way. Put these two bottom ones in, and then we'll just see where it sits. That's all right. It's a little bit close to that mount. The capacitor here. But it's being held by the hot glue otherwise, but it's not actually touching it because it moves but doesn't hit it, so that's all right. So that's cool. Sorry, it was a little bit out of frame there. So yeah, like I say, we got to figure out where we're going to be putting the servo controllers. So we need to come out of here. And we need to go into here with just the yellow one. It's just about where we decide to cut it. But either way, the positives need to come into there. I think that's what we're going to do. I'm going to replace this housing with one with just two, and we're not going to use this yellow wire. That's going to be attached via this. I'm tempted to solder it on, to be honest, directly. I really can't wait to get to get a decent studio light in there. And even my other light seems to be not wanting to play ball. So we need to sort that out as well. 5 seconds. Yeah. Yeah, my little LED light I had as a little fill light doesn't seem to be filling any light. That'll do. A sip of tea. Oops. So if we go in here, we can come out of there, we can go in there. We need to put longer cables on here to go into the receiver. And then we have the one for the pan servo. We'll probably need to go in here like so. And yeah, and then the power into the thingy bobs. So that's looking good. But like I say, we need to sort the wires out on the end of that. I might be lucky enough to have some. I'll keep an old bag of oldies. Sometimes there's a couple in there that will be good enough. But I want them to be nice and flexible, and they don't need to be carrying lots and lots of juice either. It's literally only the signal that we're worried about here. But we do need it to go long enough so we can plug into the receiver. And I'd like options in terms of how far away that receiver is going to be. And then we also need the power plug. Right, this is probably going to be reasonably ideal to power the receiver. Which is going to be coming off here. So that'll be to power the receiver. Or is it? Maybe it doesn't need to be. Maybe we can power the receiver through one of these, and then the other one only needs to have the single wire going to it. Could really do with a 4-core a 4-core cable, although ironically a 4-core cable is exactly what I made up before, but no. Not happy. Gonna have a look in some cable. Hello, Margie, my darling. So I'm probably gonna have to make, which is a real pain in the you-know-what, but I can't see any way around it. This stuff's alright. Especially for making up cable. I'm thinking in fact, I think I'd be better off just using silicone wire and just crimp my own connector on the end at this point. What's that, like 26 or something? 26 gauge? I don't even know. Where's my here we go. We need the 26. Good guess. Well, that wasn't really a guess, but you know what I mean. Might even be a bit big, you know. It's a bit overkill. Nah, that's way too big. We need something real thin, but not too thin. We need like 30. Like 30 gauge or something like that. What's that? Well, even 28 looks nice. 28. Do we have any 28 gauge black is the key. If we don't, I'm gonna have to cry. There's some 30. Yeah, 30 looks way small. We need to power the receiver as well. Okay, I've decided. We're going to need to use some... I think we will need to go for some 26 on that. Maybe even... whatever this is. Whatever this is looks good. But again, it's silicon, which is the key. That's what we want. We just like nice, decent. Yeah. And that's enough for the sort of current that we're going to be feeding the receiver with. Need to find the end of the red, which is there. And obviously I need to have enough cable as well, because I'm not quite sure where at this point. I've got options, you see, as to where I can mount the receiver. One of the benefits of my design that's quite unique, actually, I've not seen anyone else do, the design of my pan configuration allows me to not have to use things like slip rings, so you can pass power from the base to the main gubbins and where you need the juice, right? So for those that don't know, a slip ring, here's one I had, here's one I made earlier. I've got a slip ring here somewhere, I think it's in here. Yeah, so here's one. Isn't there a slightly more super duper version somewhere? Don't know. You get lots of different versions of them. Oh, here it is. You can see I've engineered quite a few things that use these, but this is a slip ring. This is a slightly more advanced version of a slip ring to show you first, but essentially you've got a bunch of wires going in and you've got a bunch of wires coming out, and this is on a bearing so it can rotate. It can rotate independently, and all the cables pass through, right? So you can put that on a shaft that's spinning. Equally, this is also a slip ring, but you'll see this has just got the two wires. So this is designed more for something simple. This is actually going to be for my globe, Earth globe, which is going to have little fiber optics lighting up all the countries I've been to. And this is another slip ring, and as you can see, slightly more hardcore. You can do a good like 15 amps or something crazy through this thing. So you've got lots of different slip rings for lots of different purposes, but the idea is it allows you to spin through an axis and still, you know, pass data and power and other things through it, right? To be honest, if you can pass power into it, you can get data anyway, because you can power up some wireless module and transmit telemetry data wirelessly, right? Anyway, enough of that nonsense. That's what a slip ring is, just so you know. And now you do, in case you didn't. Right, what we're doing? So the black and red, this is going to be the power that's going to feed the RC receiver. And because I don't actually know what sort of a receiver I might end up using, where am I going from? I'm going from here to at least there, and at least up to there. So let's go here then. So we'll chop this, and we'll twizzle this up, yeah, to make because this is silicone, it's reasonably twizzleable. Yeah, do you see? And it should keep its form a little bit better and just tease it along. Yeah. And then this will run inside the mechanism. So we want it to be nice, and of course by using silicone cable it means it's going to be heat proof and it's just far more flexible. You don't tend to get sort of random tears and things in sheath of silicone cable, but again it is just a little bit more pricey than normal PVC based sheathed cable. But when you're doing a lot of soldering, it's just actually a little bit annoying when, even at a lowish heat, your plastic sheath starts, you know, shrinking up with the heat, whereas the silicone just doesn't do it. So yeah, there we go. And then I'll just put a couple of, we'll put some crimp ends on there. So we're going to be going from there down to here, basically, is what we're doing. But it may even go into a connector in this wall plate. Have I got it here? Where did that go? I thought I got that out the other day. Where did that go? Pretty cool actually, real nice connectors, but now I can't even find them, so I don't know what happened to them. Oh, I wanted to show them off to you, and now I can't. So I shan't. Right, let's get this custom crimp done. And we want to go, we're basically going to go from a tour have we even got a tour? Of course we have. So we need to go from like 2 to a 3. And then the 3 will just help with alignment. Even though we're only really using 2. Positive and negative, and we'll grab a couple. Make sure these don't get muddled up. Okay, so we've decided we're going to make our own cables, so in which case all of this stuff, these are ours that we're using for this. Don't even know where the camera should go at this point. Just going to pop these spare cable ends in the bag. Connie Richards in the house, left me in the house. Right, sorry, just putting a load of bags of stuff away. It's getting a bit out of control in here, which happens quite quickly, as you can imagine, with this sort of work. Okie doke. So we need to have 4 of these. Just bend them backwards and forwards and they come off. And I'm going to have to, I don't even have crimpers for these. I did have way back. And then not. So we've got a couple there, we've got one spare. So I need my long nose curved pliers, are my favourite tool for this. And I need my glasses with my looper, so I can do my mad professor look as usual. And then we need our little cable that we've made up here. See, sometimes I would actually solder the ends of these to make it better for crimping, but I think we're going to be alright. Okay. Magnifying glass engaged. So where's my decent cutters in here? Okay, and then we are going to Crimpus Maximus. So I'm just going to crimp these manually. I don't even know if it will show you it. I've just folded one side over. It's very small. So, but this is what I do without. I haven't been able to afford to replace my crimpers, so I have to do this manually. It takes forever, but it actually means I can get it bang on. Ooh, there we go. Here's it, and then we'll give it a good old squish down, and we are in there and going. That ain't not going nowhere. And then we'll get this next one in. Just getting that first one in. Once you get that first one in, all good. Just folding one flap over and then the other one over. Now the problem is, you see, bear in mind, when you do prototype and engineering, this is what you have to do. You have to do everything manually. Not stuff like this, I don't necessarily have to do it like this. It's only because I haven't got my crimpers. But obviously when it comes to producing something for manufacture, I would just be ordering, like 100 of these cables already made up, going from, 2-pin JST to 2-pin JST connector or whatever I chose to go with, right? So the thing about prototype engineering is obviously you have to make everything for the first time that no one's made before and things like this, yeah. So you don't have anyone to ask, you don't have any manuals to read, you're the guy as a prototype engineer who's the guy who's ultimately going to be writing the manual for the thing you've made, because no one else is going to be able to, right? So it's just a different way of looking at it. It's not like looking at something and copying it or anything like that. It's just you know what it needs to be, and you then reverse engineer back through your mind every single little step that needs to happen in order for that to be, and that includes things like what I'm doing now, twisting up cables and putting connectors on. But although my mind maps out in vast detail the entire project of anything that I'm building, start to finish, and I know every single thing that's going to need to be done, if you were to sort of like get too hung up on it, you would never start a project, because you just the overwhelming number of really annoying tasks and things that are ahead, right? Sometimes even doing scientific based testing of devices and things can be really quite annoying and tedious, and the client never wants to have to pay for that because they don't see the results. It's like, well, we have to smash a couple up to see what happens when they get smashed up, right? Sorry. It's just what we have to do. And then you have to even just design scientific sort of viable tests that are designed to test that effectively. You know, what are you gonna, how are you gonna test it? Well, how do you anticipate that product being used by who in what environment, right? So there's loads of stuff to consider. Oh, is this last one gonna be the one that's gonna be the one, is it? Huh? Lich. It is as well. It's gonna make me want to come over there, isn't it? Don't make me come over there. Hope I'm not getting my ugly face in the way too much of the camera. It's very difficult to see what I'm in front of, you know what I mean? I don't really have any screen to review anything apart from my iPad showing me what you're saying, except obviously I've got the same delay you have, so it's about 30 seconds. So by the time I see how the camera's framed up, it's like 30 seconds ago. In fact, I have just... So that is bang on. So there we go. So let's get our socket sorted out. So we need to be, the black's on the outside, the red's in the middle basically. But you've got to have them poking up the right way. As in, so it locks into place. There's a special locking mechanism on them and it will go click. There's a second click that it hasn't done yet, but I don't want it to do it yet until that one's in place. And then we'll just use a tiny, tiny little screwdriver. Whoa! Tiny, tiny little screwdriver, not too tiny, but tiny enough to just feed those in. Boom, boom, and they both lock into place there. Okay, and then on this end, we're gonna have a tour. Is what we're gonna have. Just push those little doors in. Do the same on this end. So the reason I've put 3 on, slightly bigger one on one end than the other. And this is really nice silicon cable and well capable, more than capable of the amount of current. And so that's how it ends up looking, yeah. And of course we're doing the tour here because that too. Move that out of the way. The 2 is because it's going to fit on here as the 2, and then on the receiver end you have 3 pins here usually. I'm only using 2 of them. Yes, in fact it'd be that way up. So this will just be feeding power to this from there. That's the idea. So we'll figure that out in a minute. But for the meantime, let's plug this in here the right way around. Can't even see because the light, the light's there for you, not for me. Let me go and get my torch. Can't see from my angle at all. It's always worth double checking. Yeah, that's bang on. So that's the 5-volt feed, which will be going down to the receiver, which will basically be stuck on here. There. And this will be plugged in there, giving that juice. What else we got to do? Don't know, but let's have a swig of tea while I figure it out, is it? It's an unhappy day today, Connie, my darling. I was checking that out on Tia earlier on. She's got an algorithm that understands the moon phases, the age day of the moon, and it does seem to tie in. It does seem to tie in quite oddly. That was the algorithm I found on MIT GitHub for MIT when I was looking for a Julian to Gregorian epoch conversion algorithm I was actually looking for, and then stumbled across the moon phase / versus a motion algorithm on the same website, on the same GitHub, which was from MIT. Right. I'm happy I've got the first phase sorted with the power supply, but this next bit's going to be interesting. Right, what are we missing? Anything? I've got to sort out what I'm going to do about these servo cables. Makes me a little bit nervous because I don't really like cutting into stuff like that. And I also haven't figured out where I'm going to mount these, or even how. Although what I would say is that I noticed with these two holes here, I imagine actually these two holes are more for putting a tie wrap around it as a strain relief for the cable. Just a guess. I'm just thinking I could mount that on there. I'm going to desolder these pins is going to be my next job. Don't know. I could actually power both of these from the other spare one of the 5-volt power I've got coming out here, to be honest, and it'll save me having to run it back up. Oh no, it doesn't make a difference, does it? Because I've got this cable going to the receiver anyway. It just means it would only be, I would only need 2 wires going to the receiver. Yeah, because I wouldn't need to carry power to these servo controller boards, because I could feed them from here, going straight in, rather than having to come all the way out down to here and back up again, right? Just saying. Just saying. Let me stare at it for 60 seconds while I have a sip of tea. I'm not going to bed until I've got this thing swinging around anyway. I need to figure out what I'm going to do about what connector I'm going to use, or whether these should be mounted directly to the tray that the servos are in. Yeah, something like that. It's going to have to be one here. Again, it's important to be able to still get to these adjusters to adjust it. So that servo cable can actually just solder straight onto that. There's no reason why not. I'm just going to have to do something to protect this side from shorting out across these aluminium standoffs, so although they're anodized, but they're still going to be. There's no point in having it more of an ish than it needs to be. I just quite like the way that fits in between there. It just kind of feels like it's supposed to. Actually, not there, it doesn't. That can disappear for a second. It's just for example purposes. Does that fit out there or not? Yeah, I suppose it does. It's only just there, do you know what I mean? And I also haven't quite figured out how I can use these holes to mount it with. It doesn't really solve my problem. I almost wonder if it'd be worth sort of having spacers almost on it and have it properly secured. I do find these a real pain in the what's-its to mount. Almost be better off double-sided sticky in them. Don't even say it, Andy. I'm not, but I am just saying. Decisions. I think it's only a single layer board, so we won't have any short circuiting if it's something touching the side, but even still. Swig of tea. And I've got to do cables that are going to go. No, we don't. No, we don't. Okay. I've decided what we're going to do. And we're going to make up a tour. And we're going to do yellow and we're going to do green. Yellow and green silicon cable. Or blue. Let's go green and blue. That's usually what I use for I2C connections, but it doesn't matter. And then this is going to be the signal cable. This will be the signal basically going from what going from the RC receiver. What's going on with this? From the RC receiver to the servo controller boards. What's going on with that? What is it even focused on? This thing's just useless. Let's see what's going on there. Okay, let's do that then. So we'll have green and blue as the signal wires going from... I don't really want to do it like that, but I suppose it just is the way to do it. Sorry to say. Like it or not, that's the way we're doing it. Too late now. We're committed. We've cut the cable. Lily sausage in the house. Laughs me. If I was going to have any Zippo, what do you think it would be? My most awesome Zippo is the Sigma Prepper Zippo, which has got a laser etched forest woodland background, and this is known as an armor Zippo because it's thicker metal in the casing, just like, but it's a wolf howling in the full moonlight and the laser etched trees. This was the present I bought myself when I built Sigma Prepper as the business and the brand, basically. Stays in my pocket all the time. Sigma Prepper Zippo, gotta be done. Tell me what you think in the chat. I'll tell you what, it was super expensive as well, laughs me. It was one of the most expensive Zippos they do, the armor range. They're like $150 to $200, but it's the thing you only buy once, isn't it? And it sort of committed me to the brand. That's my style. So I saw it, I had to have it. It was so Sigma Prep, it wasn't even funny. Howl it, girlfriend. Howl it. Well, we got very similar taste in quotes and memes, laughs me, so we're obviously going to have similar quotes in Zippos as well, isn't it? Right, so what we're going to do is... What we're going to do? We're going to start off putting individual connectors on these, I think, is what we'll do. Might even heat shrink the end of it. And then we'll bring them up to those little servo controllers. That's the blue one. That's the green one. Right. Magnifying glass into place. Mad Professor look is complete. So let's get this crimped on manually with a pair of bloody pliers. I don't know if you're even going to be able to see this, but I'll do it where I think you can anyway. Boom, she's in. She is in like a good one. And then I'm going to be putting just single plugs on here, and then this is the end that's going to be plugged into the RC receiver. So I'll keep these as separate sort of pins, and then I can use them on whatever channel I want. Coming out receiver here. So we'll use a single. So we're going to want 2 singles for this. One for the green, one for the blue. Singles, I'm talking about these little chaps here, little black jobbies. Racist. So we need to give it one of them. Oh, there's a little trap door lifted up, look. Come along, old bean, don't be shy. We know you want to get in there. We're gonna have to tease it in there with a little precision screwdriver, clearly. See with that, or I'm gonna have to come over there. Boom, she's in. I like it when it's nice and tight. Tight. Right. Time for the blue one. Okay. Flies in the mix. Boom. Look at that, absolutely beautiful. That's like within, like, I don't know, 1/10 of a millimeter accuracy. Humans are pretty cool, you know, in terms of accuracy. It's very, very difficult when I consider what it takes for a robot to sort of manually. It's all very well when a robot's got everything positioned up and it's got runners and bearings pulling the wire in exactly straight and it's got all the clips in a line the way they should be. But for a robot to pick up a little clip off the floor or off the table and start positioning over the end of a wire, we're so far away from that, yeah? It's just not going to happen. Yeah. Well, I'm not saying it's not going to happen. I'm just saying not for a while. Right? I'm going to do a whole show about AI because I think AI is going to pose a slightly different problem that a lot of people aren't even considering. And unfortunately, it's already baked into the cake and it's already happened and there's no going back. So. It's defo something I'm going to have to talk about. What a lot of messing about. Anyway. So these are the 2 signals, the pan and the tilt signal coming from the controller, wherever that will be. In this instance, it's going to be just an RC controller, so we can get it rocking. And then I'll start building on that with other things. I think I will actually heat shrink this at the end to keep them together. Just got to twist it up. If you want to know what a twisting's all about, the reason why it's twisted is actually not for the reasons people think. It actually means things go around a curve better. Anyway, that's the real reason for it. If things are all straight, then they don't like to go around in a curve, but if they're twisted, they tend to. Just so you know. And I'm going to throw some heat shrink down the other end of it to stop them coming apart, because that's the end that's going into the receiver. And I don't really want to go up to the end because I don't really know how far it's going to go up, because you're going to have one down here and you're going to have the other one sort of up here or something like that. So we need to not do it all the way up. And then I'll I'll just throw a bit of heat shrink around the end of that. Keep it all together and keep it tight. Tight. And again, we're not too concerned about the end there. As long as we get the first bit sorted. So, heat shrink please. Heat shrink coming up. Looking good. So the question is, what kind of diameter heat shrink do we need? Don't know, but I'm going to be going for something like that. I've chosen this size diameter and we'll go for about this. And then we'll thread in skinny end first. Yeah, it's not a bad guess. I'll do it. Yeah. And then we've got options now. Hold on. Just getting that straightened up. And then we'll get that shrunk up. So we want blowtorch and a pair of pliers and we get medieval in your ass. So I could say I won't. Okay, so that's heat shrunk. Yeah, and then they can go into the receiver in whatever channels they need to go in. Yeah. And then we've got the cable going up. So this is the end. Oh, this is the end that's going to go into the receiver. Yeah. Power, 5 volt, and obviously that's the pan and the tilt signal. That's what we've got so far. And then these ends are going to go onto here, on this end, yeah. And then the power is going to be, I've decided it's going to be derived in there. So that's going to be the plan. Need a swig of tea while I think about it. So if I had 10,000 quid, if I had $10,000, I'd just buy one off the shelf. But instead you have to make your own. Right. So happy with that. And we're going to do another one of these that's going to basically supply these chappies. So let's heat up the soldering iron then, because we're going to need to sort these out. So that's the old one. What a mess in comparison, eh? Don't really need those out anymore. Don't need the resistors. Don't need the heat shrink. Well, we might not. We don't need that either. Pointy tool we always need. It's the most essential part of the entire life in the lab, isn't it? With Andy, the Sigma Prepper, is the pointy tool, right? It's not complete without that. Ruler we don't need. Right, just get myself some space here so I can see what's going on. Keep these over here because we don't know what we're doing with these yet. Solder nine's heated up, so that's good. Receiver can go over there. Okie dokie. Right. Thank you to the Patreon members for allowing me to buy some new Eneloop batteries for my radio mics. Because they're actually I'm surprised how long the batteries are lasting, but I bought some new Eneloop rechargeables, those black ones. And the black ones have a slightly higher capacity, so it's actually doing a pretty good job to last this. I don't even know how long I've been streaming, but it feels like it's been a while. Right, so what we're doing then, we need to desolder. We need to desolder this. And we're going to tidy it up and make it much more efficient. We're going to keep it nice and clean inside the chassis. The question is though, and I could do with taking those pins off as well. So let's just do that, shall we? We'll come down a bit lower for a laugh. Okay. We'll magnifying glass at the ready. Clean up the tip a little bit. Ouch! Just trapped my finger in the camera tripod. I look like something out of the bloody the Borg with my eyeglass. So we're going to remove this cable from here. Oops. See? Untwizzle it. That looks alright. And we need to whip off as well. We need to whip off these pins here. So the way to do that is a little secret. It's not really a secret. But we get this plastic thing, yeah, and we need to remove the plastic from it, yeah. Like that, and then you can remove each pin one by one. Otherwise, I'm not even sure you even saw that. I think it was out of frame. Oh no, might have been alright. So now we've got them off, we can just remove those pins one by one using the pliers, and I'll just get a bit of solder on the solder tip just to help transfer the heat onto the pins better. And we'll just grab each pin. Ooh, with the long nose pliers. See you later. See you later. See you later. Clean up the soldering iron. Fresh solder just to clean up those joints. Boom. Looking good. Nice. So let's clean that up then. So we've taken the wires off. We've got our input here and the output there. Or it's the other way around, sorry. That's the input, that's the output. So this is going to come in from these blue and green wires. Well, one of them anyway is going to come in. And then this will go off to the servo. So that's the plan. Question is, which way round are we going to do it? That's what I need to figure out. There's a few ways I can skin this cat. There will be future implications. But now I've cleaned it up, it's going to be a little bit easier to sort of test fit it. And the red one we decided, don't forget, is going to be the one for the pan. So that's going to be going here. Don't. So that's probably going to be going in here somewhere. I've got more options actually now. I've taken those pins off, which is nice. Happy 6 AM everybody. Happy 6 AM. I obviously haven't been to sleep yet, but you know me. That's how we roll. What I don't like is that the back of this circuit board's like exposed and you've got all the pins there that there's lots of places it can short out. I've got some Captain tape I can use, but I still haven't actually decided how I'm even going to secure it on there, to be honest. I don't really want to be using hot glue. It's a little bit low tech. And if it's sitting out there in the sun all day, every day, how do you know, right? That's why I used the industrial tape instead of hot glue when it came to the, you know, what we've been doing tonight with the, what's it? Power regulators for the servos. Which again I need to check out. I could do with firing it up with the tilt and making sure everything's okay with the tilt mechanism, and then we can make sure we're right for the rest. But I also need to chop into this signal cable here somewhere. I don't want to do it too short. And these are well expensive servos, so I don't really want to mess anything up. Not that I would, I could put a whole new cable in, it's not a problem, but I'd rather not have to disassemble, because don't forget I'm going to be snipping this wire here, yeah, and one of these is going to be going in between there and there, and it's going to have its own power coming in from this power supply regulator here, yeah, and it'll be a similar for the one down here as well. It'll have its own power coming in, and it'll be this yellow one for the pan servo that will be dialed in, so you know, that's what we got going on. Sip of tea. Sip of tea. Although, don't really have much tea left. That's quite a sad state of affairs, isn't it? Might have to go make more tea. Shazbat. Shazbat. What's that from? Shazbat. I think that's Morecambe Indian, isn't it? No, disassemble! Johnny number 5, says Last Me. Oh dear, did you see my miserable cup of tea? Or just, it's not a cup of tea, is it? It's just a miserable cup at this point. I quite like the idea of an egg timer as like going on a little short break just to go make tea, yeah? I've got an egg timer, but it's like 30 minutes and you can't really see what's going on with it. I could do with one that's like maybe, I don't know, 5 minutes or something? 10 minutes? I reckon it'd go quicker, wouldn't it? And then what I'd do is I'd position the camera or something like that. Would I even need to do that? Of course not. I just need to record it once, wouldn't I? I just switch to it. Genius. But why do that? Well, I can probably just get a clip. I can just probably get a bloody video clip of egg timer sand going down anyway, really, but never mind. I don't know. I need to sort out a little break time segment scene thing. That's the plan. And ideally what I'd like it to be is, you know, what do you call it? What do I want it to be? You know, like some bushcraft clips of some of my bushcraft that, and I don't know, something interesting for a couple of minutes, like 5 minutes. I keep meaning to do that, so that's definitely on my to-do list next for the live show, is making a segment that will allow me to do a decent break time. Especially for things like live in the lab, where I could be going for some time while I'm working through the night, as I've been tonight. And last night, obviously. But yeah, I don't think... And I really can't wait for my other studio light thing to turn up, because these little incandescent lamps here are absolutely roasting hot. So I'm going to go and make a cup of tea quickly. So I'll be back in a minute. Should I put the egg timer in the view? Could do. Is that gonna work? I wanted to get it in view of the camera. We'll turn it over. But it's kind of useless because we're talking 30 minutes, which is like not ideal, but I just want to see if it even can see it. Move the soldering iron out of the way. What a lot of fuffling about. What a lot of kerfuffling. Hey, what a load of kerfuffle. Maybe angle it down just a slight little bit. And move it there as well. Just a guess, but I'll be back in 3 minutes. I'm just going to go and sort the tea situation out. I strongly recommend you do the same. Right. Back in 5 seconds, thank you. So I'm just waiting for my tea to brew, but I just saw the comments just before I went to go make the tea about Hugo, the Where's Hugo intro, and in terms of 5-minute breaks and stuff and what sort of video to do. I thought that was a really good idea. Having the just reading your comments, it's lovely to see. It's good. I like the, you know, it's nice with the old live in the lab videos, because of course it just gives other people an opportunity to, you know, catch up with the wolf pack, innit? And people can feel like they're amongst friends while I'm working away. So I was just about to say, Leslie, right? There's you inviting everyone else. Don't forget, that's you and my home now. Yeah. Once you've edged your husband off the scene, right? And I move in, right? Maybe we're not going to want all these other people coming around our house, laughs me, right? Maybe we just want it to be just you and me for a while, right? Right. I'm going to go and check on my tea. It's probably brewed by now. Back in the room. Yeah, little turd. Oh dear. Right. Back in Bidney. So we don't need the egg timer anymore, not it's even timing anything, because it's like this tiniest little trickle of whatever that's supposed to be. It's not even sand, is it? Some sort of like volcanic ash. Right. I thought I just made a load of decisions while I was in the kitchen, thinking it through. And now I'm lost for... Oh yes, I remember we're going to figure out putting a pin on that, weren't we? Do we put a pin on it? Don't know. Gonna have to see what I've got in the way of. See what I've got in the way of options for other types of pins. Definitely gonna need something non-standard. We need single row. But we need it to be like surface mount, single row surface mount pin, or we're just going to solder it directly on, which I think is what's going to end up happening. Which is fine. I can handle that if everyone else can. But It's like reasonably down the list kind of an option in terms of what's ideal. No, it's not gonna happen. Okay. Right, plan B. We've just come up with a plan B quickly. It's 6:15 in the morning as well, so I'm going to need to figure something out pretty quick. Magic Hand will be getting up soon. Our alarm's probably going off now as I speak. Big old black crow landed on the roof. Looks like he means business. Probably looking for little baby birds to eat. Ugh. How long have we even been streaming? It's been a while, hasn't it? It's been at least 20 minutes. Oh, nearly 6 hours. That's all right now. Right, let's do it. Right, are you ready? So what we need to go posy, neggy into. So we need a positive and a negative to power these actual Visonic jobbies, but to be honest, I think we can actually use some much smaller gauge wire because it really doesn't need to be that big. Right. Small gauge wire is what we need. Wire boxes down here. So we want like 28 gauge, but I really need to find some 28 gauge. I need to find some 28 gauge black wire. I seem to be able to find the red. Let's have a good old hunt through. Oh, have I just found it? That's 30. I mean, 30 is actually, you're probably going to get away with that. Have I got 30 in red? Come on. Come on, man. Come on, man. You had one job, man. You had one job. Oh, what's that? Ooh. 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 Oh, no, that's 26. God, how typical is that? I've got every... every thickness. That looks the same as that. That's 30. We need 30 in red is what we're looking for. 30 in red. 30 in rosso. I ain't seeing nothing. Oh, hello. We're in Bidney. Although that's the reason why I couldn't find it, because it's more like pink than it is red. Red, but never mind. It'll do what we're looking for it to do. 30. 30. The 28 can go back in the box. So we're going to give... we're going to basically give each of these boards juice. Yeah, that's the plan. So we're going to make up a little cable. And for the time being, I'm going to make it up sort of like somewhat manually. So we're going to just take a bit of this up. Oops, didn't really want to unravel it like that. That's blown it. No, we're alright. We'll just chop some of that off. They're the really nasty cutters. They're for things when I don't care if the blades get blunt. These are bidney cutters. We do love the bidney cutters. Do love the bidney cutters. So that can go in my spares box at the end of that. Okay, so let's get this back in here then. And then at one end we'll double it up, you see. I think we should have a couple more. We've got one there, we need at least another 3. So let's grab our little box down. How many we got? We got 2, so we need another 2. Nice to use the ones I'm already using. Big old strip. Is that right? No, it's not actually, is it? That's not right at all. We do only need 2. Let's pop that over there. And then all we're going to do is we'll end up with a tour. But we're going to have double of these, but it doesn't need to go far. One's only going a small little way. So I think I'm going to be tempted to just cut these. What am I doing? Oh no, sorry, that's got to go over to there. I'm just getting a rough idea of how long these things need to be. And that's going to go down to there. So that's fine, we'll keep these as like reasonably long. And then we're going to just twist these up. And in fact, I'm actually tempted to pre-solder these together and then crimp them. Only because I've got 2 together and these are only 30 gauge wire, which is pretty far from ideal. Well, it's not far from ideal, it doesn't really need to be much more than that. These little circuit boards don't really take any current, any amps at all. Oh, so let's get this out of the way. Let's get my soldering, my silicone heatproof mat in play. Move some of this stuff off it. Move that out of the way. Get the whole soldering iron heating up. Right, and then we got the reds, and then we'll just quickly do a similar thing with the black where it needs to be. One needs to be very slightly longer than the other, but again, we're going to figure that out once we've got the plug on the end first, and then we'll leave the other ends loose up to a point. Again, we're going to solder these together as well. There'll be people in the UK waking up soon who went from watching me do the SHTF Intel, and they'll see me still rocking at half 6 in the morning. Never mind. Something less I don't have to do tomorrow, innit? Alright, let's just get this one tinned up. We'll just stop them from separating once we've put them inside and crimped the connector on the end. So to protect the wires, you can see here I've just used silicone tube on the end of the crocodile clips and just makes them slightly less aggressive. Especially when you're soldering PVC coated cable. You get crimp marks in the cable basically. So that's that. Where's my glasses with my magnifying glass on? I could do with a clean, but never mind. Good. Chop it down to where we need it. Same with this one. Okay, and then we'll do the same as we did with the others by manually crimping due to our lack of a crimp tool. But it's alright. We're all good in the hood. Nothing we can't handle. Nothing we haven't handled before. Talking of no crimp tool, there's my plan B crimp tool. Long nose curved pliers, not too thin. You need to apply quite a lot of force. Boom, she's in. And she is so in, it's not even funny. She is in. That is beautiful. Absolutely beautiful. And we'll just give that an extra squidge right where the wire's going in, so that's definitely never ever going to come out in its whole wide world life. Least of all when it's hit the fan and a Sentry Turret is just getting itself warmed up for a day's work. Yeah, it's not a good look, is it? So straps and braces all the way for something like this. Even down to each individually manually crimped wire. So at least I know that's not going to be a failure point, or at least it's far less likely to be. And give it one last good old crimp. Boom, straight in there. And that's how we do that. Magnifying glass out of the way. Let's feed that in. Make sure we're around the right way. Boom. That's locked and loaded. Make sure they're up the right way. Clunk, in she goes. Press those in so it doesn't want to come back out. Right, see now what we got. So what I'm going to do is I'm going to twizzle a red and a black. The ones that are the right length, and then the other two. The other two obviously are longer. So that's how we're going to do that, and then we're running two out of the same. What's it's going to each of the servo controllers is the idea. This stuff twizzles much nicer. The 30 gauge, slightly more malleable. So we don't know how long this needs to be yet, but we'll get it twizzled up ready. Then we'll do this other one. And then we've just given ourselves another couple of 5-volt feeds for our little servo controller boards, and don't forget they're different because the servos themselves want 8.4 volt, whereas these little servo controller boards only really need 5, and I can't guarantee, because I don't have a data sheet for them anymore, I can't actually guarantee they can handle even 6 volt, let alone 8.4, so I'd rather just play it on the safe side and continue those. And I'm talking about these chaps here, right? These are impossible to get hold of now. I'd have to redesign this myself, right? With my own microcontroller, which is doable, but I would need to use a very specific PWM driver thing, and I just really would not. I just don't want to have to go there. if I don't have to. I might even have to, but we'll see. So far, so good. So just doing some twizzling. We do love the twizzling. So there we go, we're looking good on that. We are suitably twizzled. Yes, we are. And now that's going to come out of there. So we know the tilt is the one that's going to be the closest. Don't know. I could actually do with a little bit more length on that, but it'll be fine. I think it'll be alright. I'm just test fitting it into the pan and tilt quickly, just to see how much room we've got. I mean, mind you, maybe it's better off being that way around. And then we got more. Maybe that's the way around I was planning. Yeah, it was. Okay, my mistake. So we'll come out to there. This one will feed down with that one and go down to here. Or something. And then this is going to come down to the receiver. And this is going to come down to the receiver as well. And we need to splice in to the servo cables as well. Oh, it's getting painful. It's getting painfuller and painfuller. And we also need to sort out this is the one for the tilt. So we could do with doing that one first, really. So I'll be keen to see it rocking. So servo's going in this end, which I think I'm going to solder directly. Yep. We'll do that. That's the plan so far. Oh, left me. Well, I'll tell you what, just talking about the hotspot there, I'll tell you what would be good. I was talking to Christina G about that, because I've got these new cases that I'm getting sorted out, right, for the hotspot. So you'll see, I don't know if you saw them before, but these are the new cases I'm going to be working with. They're aluminium. They're more like an EDC type carry, which is much better. And the other thing I like about them is it leaves the SD cards accessible. I mean, you don't want to drop it on that as the only thing, but it's highly unlikely. But yeah, the black I'm having laser engraved with the Sigma Prepper logo, right? This at the moment is just a sticker I put on there for size reference, just because I had these stickers already produced. But the idea is I'm going to be providing the Ultimate Hotspot will be the black aluminium EDC type case for the Raspberry Pi with the laser engraved Sigma Prepper. So when I was looking with Christina G the other day, it looks like it's actually easier for me to get the Raspberry Pis than it is for in America. So if you want, what I can do is I can do you just a case with the Raspberry Pi in it, and I'll figure out whatever the cheapest cost price that would be for me as a most honourable VIP anyway, right? Because I was going to be getting extra of these cases done laser etched so that they would also go on the website on the survival gear page to give people, you know, if they wanted they could have... I mean, the silver I can't laser etch, and I don't like having a sticker on it. It needs to be hard wearing, so I think the laser etch is going to be the way to go. So I've got 4, 5, I'll have 5 of these black ones, and I'm going to be, the minute the other 4 arrive, this was the first prototype to see what it was like, because they're not that cheap at all. They're like $15, $20 a pop, right? Before I've done any laser engraving or anything like that, right? Which is about the same as the other cases, but here in the UK. But yeah, I'll be looking at having those available as well, just as the cases. So I'll do options, there's no probs. And the minute the other 4 arrive, I'm going to be sending my friend all 5 of the black ones, and he's going to laser etch them, laser engrave them for me. And then as soon as they come back, I'll be making them available. So last me's absolutely in. Cool. And I think it will look pretty smart, the black anodized aluminium. And it's much lower profile and smaller space as well. So I think what I'm going to do quickly is... Which way around I'm going to do this? I think we just need to be bold and just cut through the cable and be done with it. There's no good me, like, continually avoiding it. I know it's going to be... I know it's going to end up having to go here somewhere. So servo is going to be going in the top. And again, I'm still not quite actually, still not entirely sure how I'm going to actually affix. Connie Richards is also in. Yeah, it looks pretty cool, doesn't it? Those black ones. Took me ages to find them. And unfortunately, even buying them in bulk, there doesn't seem to be any discount, like quantity discount or anything, which is a bit of an arsehole, but we'll see. But it's fine because the Raspberry Pis themselves are so rare to get hold of and so crazy priced. Oh, so that's not even going to fit in there. Is that going to cause me a problem or not? I don't even think I've got any tie wraps that are even going to fit that. But it would definitely be an option if I did. It just looks tiny. I might even be better off with blooming wire. It's not a bad idea, Andy. I know. Don't tell anyone. They'll steal it. We don't care about people stealing ideas because by the time they've implemented it, I'm already on to the next one and I'm already done my thing. So yeah, I reckon we might have to do that. That seems like an alright idea. It's not what I'd normally. It's not really what I'd normally do, but in this instance, I think I'm quite happy with it. Okay, now we'll try doing it. No, it's fine. I'm just going to cut some metal. I'm just going to cut some little twizzly bits. Right, so how long do we need this to be? We need to work out which is going at the top, which is going at the bottom. It doesn't really matter because we can feed it in anyway. So what's more important is where's the servos coming out. Servo signal wire needs to go in the top, so that makes it far more convenient. And then we've got the rest coming out the bottom, which will be, I don't know, maybe we should go in the top there with the power. No, we'll go in the bottom with the power. So in that case, circuit board's going to be there. Wire's going to come around here. Little bit of flex on it. It's going to need to come to here. We don't want too much flex to the point where it gets into the gear mechanism, and obviously I shall probably secure it somewhere. But by the looks of it, we need to be there. Too late now. Yeah, that's the Pi. Well, no, I've managed to get some Pi 1s, which are even more rare, which is good because the Raspberry Pi Zero version 1s says Raspberry Pi Zero is what we're looking for, and but the Raspberry Pi Zero original versions are better if you can get them because they're far more efficient. They're nearly 50% less power they use, and everything else is the same CPU, same RAM. The only thing that's different on them is the Bluetooth chip I think they updated, and all that results in is instead of 0.43 watts, it uses 0.68 for some reason. I don't quite know what Raspberry Pi were thinking by making it consume so much more power for not really any benefit, just some extra Bluetooth thing of which the hotspot doesn't really utilize that. So that's like pretty much already kind of where it needs to be really, so let's keep that about the length that it is. Okay, so this is our power supply feed for the little servo controllers. So what we need to do is just tin up the ends of these wires, and then we'll actually fix these to those little boards, give them power. I can even strip back the silicone. Is difficult because these wires are so thin. Definitely going to be having some cereal before I go to bed tonight. Let's get that soldering iron preheated up. Is that even in shot? Slightly. Solder please, Bob. Move that out of the way in case we get a blob of solder drop on it. That's never a good look, is it? Excuse my face if it's in the way. Excuse my ugly mutt. Okie dokie. And then we'll do the same this end. Tin up the wire, ready to solder on the circuit board. Yeah, so in terms of screen, the Raspberry Pi, you don't actually need to plug a screen into that. It won't show you anything if you plug a screen into it, because it just beams it out like hotel Wi-Fi, yeah? Like a hotspot in a hotel. That's how it works. So you just need your smart device. Like a cheap tablet's a good thing to go for. Or even just your usual smartphone, yeah? and then just instead of connecting to your home network Wi-Fi, you connect to the Sigma network, which you'll see pop up when you fire up the hotspot, and then you just look at it. Oh, then you just look at it on your phone. Shall I demonstrate it now for a laugh? I will in a minute because the cable's right away over the other side of the room. Right, so this one's soldered up. That's looking good. I'll just trim those down to be a little bit more what I'd want to solder on the end of the circuit boards. And then this one here. So you can see they're quite thin little wires. This is what we're working with. And again, the camera's struggling to focus, but it's cool. It's no biggie. We're alright. We're used to it. So yeah, this is these two cables are for powering the servo controllers. So they're going to be soldered directly on, but they will be removable. And then what we also need on here, which again, I don't actually know how long this needs to be yet. So I think for the time being, we're just going to keep it that length. And because I'm going to solder it on, it's going to be quite easy to just change the length when I need and resolder it. So I think that's what we're going to do. We're going to keep it full length, and then we can do a dry run where we can power it up and see her scooting about. Let's see her scoot. See her scoot. Hoo-ha! Where are these going? These are going on the Visonics. It's Vision Locks. Sorry, I keep calling them Visonic. Visonic is a wireless home alarm system. Green first. Blue next. It's good. Bit long, we'll shorten them up. Again, sorry about the massive face in the frame, it's just how it is. So we need to decide what's going to be pan and what's going to be tilt. And we'll need to, and don't forget the difference between science and messing about is just writing it down. So that's what we're going to do. So pan servo. I keep wanting to say blue, so pan equals blue wire, and then we want tilt equals the green wire, and that's how we're going to do it. So boom. So pan is blue. The deal has been done. We know that this one here with the red on it is the pan. So we already know that we can quite happily sort that out. So let's do that now. We know that blue's the pan, don't we? So hold on a minute. Hold on a minute, son. Hold it, son. Okay, just trying to keep this together a bit more. It's just it's very untwisting itself like this is. Right, so pan is what we're doing now, which is the blue. So let's engage magnifying glass. Which way round are we doing it here? This way round, isn't it? So what is this one? This is the pan, which is the slightly shorter one, I think, isn't it? So positive's going to be in the middle. So let's get that dialed in there to give it juice. Looking good. Looking very, very good. Very, very good. Oh, le magnifique. Le magnifique. So that's the pan on blue. And then we need this one here that we need to decabilize. And no, I don't know if decabilizing is a word or not, but it is now. Let's see what that's me saying. I'm assuming my home Wi-Fi, much everything else, would be down if I'm accessing hotspot info. Yeah. Yeah, so you've got grid down scenario, you've got no Wi-Fi, and then when you power up the hotspot on your mobile device, which you should have battery power for and a USB battery bank, you go on your Wi-Fi. In fact, the only hotspot you'll actually see will probably be the signal prepper hotspot, because obviously your Wi-Fi is probably not, your Wi-Fi router is probably not going to be connected either to the net, or equally it's not going to be powered. So really the only hotspot you're going to see when you go on your Wi-Fi settings on your device will probably be the signal prepper hotspot. That's the benefit, you can spark it up with nothing more than 5-volt USB battery bank. And you're in Bidney, girlfriend. Bidney. Did that just take the fucking track off? No. That was scary. And then what was the next bit? Accessing the info, not so much utilising the hotspot screen to see all the lovely bits you've loaded. Yeah, that's why I prefer to use, I mean, I use my iPad with a hotspot and that works out quite nice. You know, the iPad's a little bit buggy because I have to use the Chrome browser on the iPad for videos. Everything else is alright, it's just like things like the Canadian prepper videos I got on there and that. And I've got, I think, the entire collection of Crash Course as well, like home education, but it's actually for adults as well. It's pretty cool. Oh, hold on, we need to remove the black plastic bit here, or we'll never get those pins off. Okay, let's grab that there and see if we can get these pins off. Get some solder on there, get your old pliers out. You should be able to pull these off one by one. Unos, dos, tres. Looking good. Okay. So we need to do a similar situation this end. She's bubbling. She's bubbling. Okay, so we're going to do what we've done on this end. Except obviously the green one's going on there. Let's do that now. In fact, I prefer working left to right, just because otherwise the soldering iron ends up getting in the way of the... I've could probably do with cutting them down as well. At least just a smidge. How's the green one? That's alright. Okie dokie, so we want left to right, black, red, green. Black. Can't even get the angle on that. There we go. Like it, like it. Because I did say I wasn't going to sleep until I got this thing fired up and rocking about. So this is going to be it. Oh, me hearties. Oh, me hearties. Would you look at that? Oh, would you look at that? Okay, so it's fine as a temporary measure. Well, it's only slightly temporary. Okay, so the next bit's quite tricky because this is where we start the destructive elements, having to cut into the servo cable, but it's just part of what we have to do. It's just we just need to decide. We need to decide carefully and make sure we don't sort of leave ourselves with not enough room on the end of the wire. Just putting this back in a little baggie. Yeah, so I think there's a Lenovo ThinkPad or something, Leslie. I think if I was going to get an iPad or a tablet, it's like I think they're pretty good. Like really cheap as well, right? Like a 10-inch Lenovo, is it, or something? The old Android tablets I think I'd get rather than an iPad. It's just cheaper for me to get an iPad because here you get them on contract, right? Otherwise you just have to buy it, which is Epic Sheets. I appreciate that. But any smartphone device is good. But yeah, like you say, it's nice to have the big screen. So definitely tablets what I recommend for that. So how are we doing? Not bad. We just got to start chopping into these servo cables, which is like, just makes me nervous because these are like $280 servos each. Each servo is $280, right? So I just can't afford, obviously, for anything to go wrong. But as long as we leave enough for this wire, we're going to be fine. So just need to get in there, yeah? And just give it one and then it's job done. See how quick that was? So we don't need that to go down to here because, of course, we're feeding that in from somewhere else now. And in fact, what I need to do is, first of all, take that out of there, really. But I don't know if we're going to get away with that. But these are going to be nasty. Are these even going to be compatible with the other ones I've got? Because ideally I need to take these out and I need it to be just 2 pin to fit into the regulator. There we go. So we take that out. Problem is, I mean, we're going to have to chop that, or I have to put a different pin on it. I guess we'll figure out which one that's going to be, depending on how well this goes. don't know if we've got away with that. It's a bit close, but just chopping it down so now it's only got 2 instead of 3. Yeah, because don't forget we're now going into these pins here, right? So we know that negative's on the bottom. This is the tilt servo. Right. So let's go to the top one for the tilt. Ooh, it's going to be in the way of that pin, isn't it? I wonder if it would be. I don't really want to remove that. Just don't know if we're going to be left with no choice. Don't know. Where's my file? Just filing down the plug. It's not the best solution, but it's better than kicking a you-know-what, as they say. It's not happening. I'm going to take that off and be done with it. Okay, so that's the servo juiced up, right? That's giving it power. And then this is the signal wire. So I'll obviously shorten this anyway, and I'll put a new thing on it to go on there, right? But for the time being, it's fine, and I'll put probably some heat shrink on there to stop it unraveling, which I'll do when we've taken that off. So this is just going to be soldered directly onto the little servo controller board. But it's nasty wire that's going to start shriveling up the minute we even show it. The minute we even show it the soldering iron, it's going to go. Whoa. But there's not much we can do about it. We just got a steam in there. Morning, magic hand, my darling. Nearly done. My famous last words as far as magic hand's concerned. Nearly done. Right. Slightly thicker cables, so I'm going to use my slightly not as quite as expensive side cutters. So we'll chop that off, and this here is going to go onto the this is the tilt one, so this is going onto there. So because of our restriction here with the wire though, I wonder if we should lay that down. That might work. We can bring this out to the side here then, and then we can bring this in the mix. And you can see here where this arrow is where we're going to be rocking. If I can even get to the soldering iron now. Bit of solder. Job done. So I'm kind of tempted to. I'm kind of tempted to get that fired up, but before I do that, I think we're just gonna chop that out there and just make the decision that that's where we're gonna go from. Again, we're gonna remove this cable from the servo plug. So we don't need it. This is the one that feeds the servo with the signal as to where to go to, but we're going to have to remove it out of there by just lifting that little flap up like so. Pull that back, and then I can use my side cutters here just to trim this down. In fact, we don't need to do that anymore. As long as that one's removed, it's fine. That can plug straight in. So let's do that. And then we'll just right, we'll get that tinned up wherever my solder's gone. Someone's stolen it. I've been robbed again. Certainly have. Ain't not seeing no solder, nothing or nothing. Yes, please, honey. Oh, well, I have got a look. My tea's not looking too atrocious. I'll have to come and have some cereal before going to Kippity Kip Betty by Bubbies. Where's my solder? Who's stolen my solder? I'm gonna quine till I'm thick. Right. Alright, we'll just have to pull more off then, won't we? Nasty. Okay, and then this is the pan. Let's make sure we ain't getting all twisted. Man, you getting it twisted. Oh god, have we already got ourselves all twisted up like an absolute twisterer? Okay, there we go. We're back to not being twisted. Okay, so this one needs to be going on here. So I'm gonna have to be this is gonna have to be a three-handed. This is gonna have to be a three-handed affair, basically. We'll see how we get on with two. I need to hold that there. I need to hold that in place. But that's well nasty, it needs to be. More like that. Ow. Look at it, it's floating above it. Okie dokie. So we're gonna feed that one in there. So servo's powered up. So what we're left with now this is essentially, this is kind of like it, right? We'll see. We're gonna have a little look at it and see what it does. But I think we'll be right having these dangling for the time being. So let's get this plugged in. Let's get this plugged into up there. Where's that going then? Plus is on the bottom. Plus on the bottom. So we've got those two in there for the 5 volt. We've got these two in there for the 8.4 running the servos. We've got our two servo controller boards here. We've got the red on the pan, that's right. We've got the non-red on a tilt, that's right. And then we end up with these two cables at the end of it, which is power and a signal. So should we do it then? Should we plug her in and see what happens? Yes, let's do it. Okay. So we want to give it some juice. We'll just run channel 8 for juice. See what I'm looking at. And then we've got the signals here, so we know that the pan's on blue. The pan's going to be the aileron, which is channel 1, and then tilt is channel 2 here. And of course, as you see, we've got 8 possible channels. There's actually 16 channels I can use on this to break out into another 8 of different things I can turn on and off and vary and everything. So this is how we're looking then. We've got power to the receiver, which is what that 5 volt regulator was for in the first place, yeah, that we did on here. We've got the two signals controlling the two different servos. Let's just get a bit of a wider angle on it. I'm going to pop this down here. There's a bit of double-sided on there. Okie dokie. So, a little bit of a bird's nest at the moment, but obviously we're going to be fixing all this up so you won't even, yeah, it's going to be good. But I just need to make sure that the actual wiring's working okay. So what we need to do then is to start up Magic Hand in the house. Hello, Mr. Hugo. Hello, Hugo Bear. You come to say hello to Daddy? Hello. Oh, isn't he a handsome boy? Hello, baby. Hello, baby. You have a nice sleep? Oh, look at all the sleep in your eye. Come here, let's get a wet wipe on your eyes, boy. Got sleep hanging out of the place. All your friends are online, Hugo. There we go, that's better. That's better. No massive eye bogeys. There you go. Right, where's Mummy then? Hello. I think I'm alright actually. I've got 2/3 of a cup and then I'm going to be rocking to sleep anyway. It's because I'm pretty much done it. I'm just about to fire it up. Nice what? Subscriber count? Yeah, I know. 410, the same as it was. Nice that. YouTube loves me, yes they do. So let's boot up. Let's boot up the main control.
Sigma Prepper. Reject the herd. Prepare the pack.
Good advice.
System. Disarmed. Manual mode. Flight camera. OSD enabled. Navigation lights disabled. Flight mode 1. Auto launch.
Okay. So, we are booted up. She's trying to connect, so we're good. So we're good to juice it up. Now this is going to be tricky because kind of anything could happen. So, and usually anything will. It's just tricky to make sure I don't have my hand taken off. And just in case it does take my hand off, I might as well document it. Might as well get a viral video out of it, innit? Right, here we go then. Let's boot her up for the first time, see what she does, and I'll be ready to remove the power. Try and hold it still. Whoa. Oh. So slightly off center, let's just adjust that. Ooh, look, you're seeing it for the first time. You see, it was worth waiting for in the end after all, wasn't it?
Trim center. Trim center. Trim center.
What do you reckon? It's alive! Oops, I'll tell you one of the problems. Is I need to hold the base because it's just. But that, oh shit, she is super, super excited to be alive. You can just. What do you reckon? Let me know in a chat. So that's looking all the way up, yeah? That's looking all the way down. Oof, bloody hell. This thing's about 20 kilos. The way this thing throws itself around is quite impressive. And the pan's actually twice as fast as the tilt, because the tilt is twice as strong as the pan. So you can imagine what I'm talking about in terms of what you can decide. Right? I think you get the idea, right? And so what I'll do is I'll put in the frame. Let's move that battery around the back there slightly. And I'll just raise you up and see if I can get both the RC controller and the Sentry Turret kind of in view together, and then you'll be able to see sort of what I'm doing to control it, if you like. Yeah. Might have to come down an angle more like this though. And of course I have to wait until it comes through on the iPad to see what it looks like. Oh, sorry, I'm having to adjust this camera. So I think that's roughly thereabouts. So we can angle it up slightly. So I hope that my stick's still in view. Oops. It's quite difficult to hold. So you got. See, I'm pulling back to go up, or you could do it the other way around. See, if I move the stick a little bit, it will just hunt in that direction slowly so you can get real dialed in, right? If I hold the stick down slightly, it will start moving up slowly. Right, so you can make really, really detailed movements as you're tracking a target around, yeah? I'm sure you can imagine what I'm imagining, right? And bear in mind, you'd have also mounted on the top, you see, would be your 30 times zoom camera and some form of night camera. This is night camera as well, but this would be looking through whatever your scope is. I'll need to dial in the trims and stuff, obviously, it's only just put together, so that would be mounted on the top of the top deck, so that it would be looking at whatever the pan and tilt's looking at, yeah. So I hope you're happy with the wiring we did. Obviously it's not complete yet in terms of, you know, there's lots of tidying up to do with the wiring, as I'm sure, as we followed it over the last 6 or 7 hours or whatever I've been playing around. But it's looking nice. I mean, this is all, you know, proper silicon cable now. The power supply unit is 1,000,000 times more efficient with space. It's more solid, it's more reliable. And of course I'll secure these things in place, and I'll cut the wires down so that they're exactly the length they need to be, and there won't be any excess and so on. So that's the plan. But yeah, I'm pretty super happy, I am. It's just lovely to see her back in action, yeah?
Cruise mode, acro mode, cruise mode, manual mode, system armed, system disarmed, system armed.
So yeah, super happy, yes I am. And you can see what I mean about the blue light shining up on the inside wall there. It's blatant, man, so we can see she's juiced. She is juiced. Right, so the next task is going to be getting the top deck section done. By the way, there is actually a cover. There's a cover here. Let's turn it around this way so you see the back. It's probably easier to demonstrate, even though we've got the battery pack plugged in the back. This will be at the top normally, but this is like a plate. You can see these holes that I've drilled out here fit in line with these other thingy posts, yeah. So this cover is it going to let me do it? Not supposed to have wires at the bottom there, but I think you get the idea. So that would go in there. It fits in there perfectly, and the cover goes, you know, sort of curves over like that, basically. But you can see there's a recess. That's why I designed these side plates, yeah. Just as a quick thing, you can see these side plates here. The reason I did this with two layers of 3mm aluminium is so I could have this recess here, yeah, in the design, so that when this is, obviously this would be further down, but that light's pretty nasty there, isn't it? Sorry. But you can see this would be like that. Need to be careful where I'm getting my fingers. So, yeah, there we go. So this sits in there perfectly flush, right? And it sort of gives it like, it's weatherproof, and then that would curve around. And you can see it's like perfect. Beautiful. So it's going to look bidney. Gonna look Britney. It's gonna be cool. So that is my ultimate Sentry Drone turret. Sentry Drone turret thing. Yeah. I hope you like it. It's one of my most complex prototype engineering projects in terms of cost and machining and aluminium. I need to get the side mounts on and tighten these up, yeah. So we've got the entire top section that goes on there. But yeah, I'm super happy about that. So let's disconnect the power. Tia's probably going to moan at me because she's not going to receive any signal. In fact, I'm going to unplug it from here in case it psychs out. Tia should detect that she's not connected.
Telemetry lost.
Telemetry lost. Time to shut Tia down. Boom. Should we hear Tia one last time? Boot sequence.
Sigma Prepper.
Oops.
Reject the herd. Prepare the pack. Switch warning.
Oops. SB.
System disarmed. Manual mode. Flight camera.
And that
OSD enabled. Navigation
is
disabled. Flight mode.
very
1.
wrong.
Auto launch.
So, I hope you like it. Now you know what I'm talking about with the old Sentry Turret. Once it's finished and it's on its tripod and it's pegged down with cables in the lawn. Dong 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 dong. Yeah? You'll yeah. You'll know what Guam. If you know what Guam. Right. Let's put things back in order. And then we can head back over to the main screen, of which may or may not work. Here we are. Here we are. We don't need this anymore. Thank you everybody for joining me for this live in the lab with Andy, the Sigma Prepper. For whatever the date is today, the 12th is it or something? I don't even know. I don't know what day it is. It's the 12th, isn't it? We've been going for nearly 7 hours. A 7-hour live stream dedicated to, I mean, yeah, I guess that's just how much time it takes, yeah, to build these sorts of things, prototype, lich from scratch. Although, if you want to make an apple pie from scratch, you first need to make the universe, but you know what I mean, and all that. Little studio light. Well, it's not even a studio light, it's like a little AD light. I was using this earlier on as a fill light for the subject, but it's a small little battery in here. It didn't last. The battery didn't last very long. So thank you so very much. Absolutely worth waiting for, said Connie. And thank you everyone for being with us. It's been fun. And it's nice, you know, maybe for you to get to see what I'm doing behind the scenes for Sigma Prepper in terms of, you know, ideas I'm sort of thinking to bring into market and other stuff. So I'm really looking forward to getting involved in more things. Really looking forward to those, Raspberry Pi hotspots, getting those EDC type things I found, the aluminium ones machined and then, you know, laser etched, laser engraved with the brand in that. That'll look really cool. And of course, I will make that available separately in different levels of things that you can buy separately for it. So that'd be cool for those that haven't managed to get themselves a Raspberry Pi or a full kit or anything, or just a case. I'll be able to hook you up. So that's the idea. So I'm going to go and have myself a bowl of cereal and yeah, and see how much sleep I can get before doing this all over again when I wake up. But I am planning on doing an SHTF Intel report later on today, believe it or not, Friday. Otherwise, I'm not going to have much to recap on the walk and talk, which I'll have to do tomorrow, which is Saturday. It is Friday, isn't it? It is. So Magic Hand film night. Look at the state of my eyes. This is what going to sleep at 7:30 in the morning does to you. But it's cool because I'm super pleased that I've got my babe figured out. Super reliable. It's a real good platform for me to work with as well, so I'm really pleased. So thank you so much for being with me. Thank you so much, Margie and Connie and Lasmi. Thank you for the super chat earlier as well. I really appreciate that. Fine, wonderful wolf pack. Such an amazing group. So thank you so much, and I'll catch up with you in way less than probably about 12 hours time, 7:30. Yeah, about 12 hours time. We'll do it all over again. It should be good. And in the meantime, thank you so much, everyone. Again, it's been lovely. I've thoroughly enjoyed getting it. I've thoroughly enjoyed getting it. Getting it working again and seeing her spinning about nicely with all the wiring the way it's going to be. So watch this space. There'll be more coming on it. We'll be doing more live labs. So live in the lab. And again, thank you for everyone over on the Discord server. I was just looking at Ghost Cowboy there with his key ring he posted. Thanks for that, my man. So thank you again, and I'll I look forward to seeing you in about 12 hours time. So I suppose in the meantime, you know who I've been, this person here. You've been an absolute wonderful wolf pack. So yeah, love, peace and progress.